Welcome back, everyone. We are here for day 9 of the completely free Go Cloud Careers Azure Solutions Architect Expert training. And this just training is to prepare you for the Azure Solutions Architect Expert exam, otherwise known as the AZ305. So it's been 9 fun days. If you're just joining us now, you can watch the previous 8 days. They're going to be stored on our YouTube channel. And in the event you're just joining us, please note that on the first day, or the first week, I should say, we covered honestly what you really need to know, how the technology works to a degree, what are these actual technologies on the Azure platform, and we really focused on getting you good, strong Azure fundamentals and cloud fundamentals. This week, we're kind of doing the Azure Solutions Architect Expert official training, which is more designed to help prepare you for an exam as opposed to what we did in the first week, which is designed to give you the skills and knowledge for a cloud computing career. They're completely different things. There's a big difference between certifications, which are kind of more about the name that a company would call it, and knowledge about the career. So we tried to give you a lot of bonus material in that first Azure Fundamentals week. And now we're on that specific certification material. So if this section's a little drier, that's why. You know why. Because we're not just trying to prepare you for knowledge. We also want you to get you to pass this exam. Bear with me. I'm going to mute my phone. Apparently, I forgot to mute it. And I get about 10 messages a minute and a couple of calls per minute. So I want to make sure we did that. So, we'll begin in a few minutes. And before we get there, let me know where you're at. Where are you in the world today? I'm in South Florida over here. I know Leo Paredes, who's here, is in Sao Paulo, Brazil. And I know Mark is over there in Tampa, but where are you? Let me know. And I also want to get a hashtag AZ305, Alpha Zulu 3-305 to let me know you're awake, alert, and oriented, because that AZ305 is actually the Azure Solutions Architect Expert exam. And that way you actually know to take the right exam. When I start seeing where you're from pouring in, and I start seeing some of these AZ305s coming in, I know you're awake, you're alert, you're oriented, and you are ready to go. And then I will actually begin the training. I love it. Nigeria. Tom is in the Netherlands. I remember you're over there, Tom. Jersey City, Ben Kim. I actually worked in Jersey City at Night Securities many years ago. Ebenezer, it's so good to see you over there in New York City. So start to see where you guys are from, which I love. DC, obviously. Derek, so good to see you. Always happy to see people that I know, like Jason and Derek and Emmanuel. Renato is over there in Canada. Absolutely love that. In Ontario. I'm sorry, I meant Canada. I was thinking Canada, where I did a lot of work with Alcatel, which was also in Ottawa. Which is in Ottawa, not Ontario, and New Jersey. And like I said, I have a house right inside of Princeton, New Jersey, and it's a place I've spent a lot of time in. Although these days I kind of try to spend as much time as I can in Florida. The warm weather is a little better on my joints that have had about 30 years of powerlifting and martial arts. So feels much better in the warm weather. So where we left off yesterday, we were talking about some databases, and now we're going to talk about data security, specifically for data that's at rest, in motion, and in use. So we're going to talk about transparent data encryption. So the whole point here is to protect our data privacy, because we don't want our data to be viewed. We're here to try and maintain compliance with any type of regulatory standards. For example, if we had medical data and it would be exposed in the US, we could be subject to a HIPAA violation. Or it could be PCI DSS data for payment cards, and that for compliance purposes, it needs to stay there. And data sovereignty is something else we're talking about. Data sovereignty is more related to keeping your data in a geographic area that's required for legal purposes or compliance purposes. So we want to protect and mitigate the risk of unauthorized access or offline access to raw files or even our backup data. And how do we do this? Well, a lot of it we can do it with encryption and decryption. So when we're dealing with transparent data encryption, the encryption and decryption are going to be performed at the page level as data is written or it's read. So When it goes to storage, it's encrypted. When it's pulled out of storage, it's decrypted, and it's going to be, realistically speaking, in real time. We want to do the same thing for our backups, because if we back up all of our data and we don't encrypt it and someone steals our backup, they got access to all our data. So I hope that makes sense. And when we use transparent data encryption with our databases, we have basically a database encryption key. And this uses symmetric key encryption, which means we're using the same key to encrypt and decrypt. So that's what we're really talking about. So when we deal with this database encryption key, we can either have a service managed or customer managed. So if it's going to be service managed transparent data encryption, the database encryption key will be basically protected by a built-in server certificate. But if it's going to be customer managed transparent data encryption, the customer themselves are going to supply and manage the TDE protector and a key management system. So keep that in the back of your mind. And when we're dealing with an always-on availability group like we talked about, transparent data encryption can be used with databases and basically in the availability group. And they're basically going to be sharing the encryption certificate across the servers. Let's talk about data in motion. So if transparent data encryption encrypts when it's stored and decrypts when it's pulled from storage, what about the data in motion or in flight between the database and wherever it's going? Now, here is another place to use encryption. But typically speaking, we're not going to use transparent data encryption here. We're going to encrypt with that SSL/TLS or TLS method. Now, a lot of times you call it SSL, and we used to use that secure sockets layer as encryption many years ago. It's not strong enough, so it became TLS, but many people still call it SSL, to keep that in the back of your mind. And that's things like we might use it for email messages in transit, that HTTPS if we're browsing a website. So keep that in the back of your mind. It's always going to be encrypted when it's in motion. So let's talk about some things to really think about. The point here is to make sure that all encryption is done between the client and server. So encryption means that I can authenticate the server. If I'm going to try to buy something from Amazon, I want to know that it's not as Amazon, as opposed to somebody creating a fake Amazon website that's just going to collect my credit card information. And encryption will provide that endpoint verification that we're talking about. So that's why we're doing it. And when we deal with databases or Azure Managed Instance or Azure Synapse Analytics, it's going to support natively that TLS type encryption that we're talking about. So let's talk about some possible security solutions that we could talk about with regards to our data moving. So one possible option is to basically secure our on-premise access to the Azure VNet. And by doing so, we got lots of options here. If we have a VPN between our data center and our cloud, that IPsec is going to provide encryption, which means our data privacy. It's going to provide that endpoint verification. It's going to provide hashing to make sure the data hasn't been changed along the way. And it's going to provide that concept of non-repudiation, because the messages themselves are sequenced. We're going to make sure that you can't say that you didn't send the message. And if you'll recall, if it's going from you to the cloud, basically speaking, it's going to be a point-to-point VPN. That's kind of like the VPN client you might have on your iPhone, which mine has a cat photo on it, my cat Cindy. But it could be your PC or Mac with a VPN client or your Linux system. Now, if we've got multiple systems, we're going to use a router to do it, and we're going to call that a site-to-site VPN. Now, if we've got to move a lot of data between us and the cloud provider, or we need guaranteed data performance, we're going to use a private line. Azure likes to call their private line express route, so we'll use that for our wide area networking link, the links over the distance. So let's talk about Azure storage interactions. So generally speaking, when we're going to store something, we can use HTTPS. And it's going to use an Azure Storage REST API, but we're really doing it to get it there. But so think about it. If you're going to send your data, you're going to send it typically over HTTPS, which means, again, it's encryption. So that's what we're dealing with. And so let's talk about data in use. So data in use is data that's being actively used or currently being processed. Here's an example. If you write an email, you save a file, or you order from a website, that's data in use. And typically with this, we use an encryption method called dynamic data masking. And the encryption level is going to be specific to the data that's basically unencrypted, because we need to make sure our data remains encrypted. So that's what we're talking about. Some data may be unencrypted and some data may be encrypted. So let's talk about some things that you should really know about some dynamic data masking here. And the point or the purpose is to protect data while it's being used or changed and to limit access to sensitive information. The implementation here is going to be, why we could do it via policy-based security. And this is going to hide sensitive data in query results and while keeping the database unchanged. So you may not want everybody to query the database and get access to all the information. That's data masking. They actually do a really nice job discussing data masking in what I call my favorite intro to cybersecurity training program, the CISSP certification. That's some great intro level certification in security. You do it, it teaches you so many things. And I typically like that. I teach that to all my students, the CISSP. That's my intro to cybersecurity, and it gives you a concept of what you really need to know for these careers. So when we deal with these things, it gives us an automated discovery. So we can use this to identify sensitive data and make recommendations on what data needs to be masked. And at the same time, with regards to configurations, we can set it up and say the Azure portal. We can use PowerShell commandlets, that type of thing. So let's talk a little bit about design for Azure SQL Edge. And edge computing, the whole point here to remember is to get closer to your client. So we talked about in your data center, you've got really great performance and low latency. You go to the cloud and now you've got a wide area network and you've got more latency just going to the cloud and just back and forth than you typically would have with all your systems on premise. But so if we've got latency sensitive applications, we may want to run them on the edge of the network. And there's lots of ways that we can do it. But where it really comes into play is when we're dealing with things like Internet of Things or IoT Edge. So if we've got a bunch of weather sensors or self-driving cars or planes that are over IP, we want them to get the information as fast as possible. A plane flies at about 500 miles an hour. You can go pretty far in a second or two, right? Or even if it's and milliseconds themselves can actually be a reasonable distance at something like that. If we've got a car that's self-driving and we can save 5 milliseconds off the time that the car brakes when it sees something in front of it, that could be the difference between saving a life or not. So when we're dealing with Internet of Things, we want to reduce the latency. So wherever they hit the network, if we can put servers there, that's called edge computing. And a lot of time what you may see is where the mobile phone companies have their 5G data centers, the cloud providers will put their servers directly in those data centers. So you've got a mobile device. As soon as it hits the network, automatically the compute is in the same building. That's what we're talking about. So Azure SQL Edge is a relational database that's optimized for Internet of Things and edge computing. It's built on the same engine as SQL Server and Azure SQL, which means it's got that kind of developer compatibility. So if the developer is used to writing SQL Server things, they can reuse it on Azure SQL Edge because it's the same thing. It's just sitting closer to the users for the most part. So if we're dealing with streaming or processing or analyzing relational or non-relational data, that's kind of the capabilities of Azure SQL's Edge. It works often with containerized applications. The platform is going to be Linux-based. And it can be set up with a startup memory footprint of less than 500 megabytes, which is nothing. And really the key is this IoT device compatibility. It's designed for you to build applications for various IoT devices, capture data streams in either real time or integrated into an organization's data solution. But we're trying to do it at the edge, enable the processing at the edge closer to the user. So let's talk about some characteristics. There's a built-in streaming engine. And what does that do? It functions to transform the data or find anomalies or classify the various data streams. And it also is good for time series storage. So we can use it for index data, which could be aggregated and stored on our main cloud for future analysis. but a key is it's on the network edge. So interacts with edge gateways, IoT devices, edge servers. Closer to the user means reduced latency. Now there's a couple of additions we can actually talk about here. There's Azure SQL Edge Developer, and that's basically really small. So 4 cores and 32 gigs of DRAM, which is not a lot. So you may want to use that in a development and testing environment. It's not going to scale for real production use. And there's this Azure SQL Edge, which we've got up to 8 cores and 64 gigs of DRAM. So it's production use. Again, this is not a powerful system, but it's going to be enough in most cases for the light use. And we may have this in various different edge data centers throughout the world. So when we think about securing it, there's a lot of things that go into it, and that's going to be way outside the scope of this. But we'll talk about a few things. So we can think about platform security and system security. So if we've got it on a host, like a virtual machine with Docker, we've got to lock that system down, disable unnecessary services, install some anti-malware, put some host-based IDS, IPS systems, and host-based firewalls on that system. Ideally, we've got some good network layer security that we can use too, but like firewalls and other things. We want to make sure we use some kind of authentication, authorization, and accounting. So at the bare minimum, use a username and password, and make sure you've got authorization permissions to determine what you can access. We also want to use some database object security. So we want to really secure the server, the database, and all objects on there, and make sure we use transparent data encryption so it's always encrypted. And of course, when it comes to applications, we want to use good application security. So that involves, things like the way secure coding practices, testing these systems, code reviews, looking for things like input validation so you can't enter certain things from the user perspective that are going to crash the system. Those types of things are going to go into this. So let's talk about some deployment options. Well, we can do a connected deployment, and we're going to get that in the Azure Marketplace, and we can basically deploy it as a module for Azure IoT Edge. We can also do what's called a disconnected deployment, where we use Azure SQL container images from Docker Hub, and we can deploy it as a standard Docker container or on a Kubernetes cluster. So when you think about the network, the design considerations are you need to have the network connectivity. You have to think about the latency that's necessary, the bandwidth, or how much data you can send. And if we're going to have slow or intermittent broadband connections, we still want to continue operations with a local database, and we want to try to eliminate latency by not forwarding all the data that we don't have to the cloud. With regards to data security and privacy, we'll think about Azure role-based access control, attribute-based access control, encryption, data classification to make sure we control access to whatever this IoT app data actually is. And we're going to also try to consider and design, what's the synchronization connectivity going to be with the backend systems? Because we want to easily exchange data, whether it's with Azure SQL database or SQL Server, or if we were to use a proprietary NoSQL database like Azure Cosmos. What's nice here is, Microsoft SQL Server has been around for a couple of decades. So it's typically very easy to find a developer that knows how to use this, and they don't have to go look for super developers because it's been around forever. So we can reuse code from old applications for SQL Server, and there's a lot of people that actually understand SQL Server, making it more of a commodity hire, meaning less costly to the business. If it's a rare skill or a complicated skill that's still in demand, it's going to be a super expensive skill for the business. If it's a commodity skill, like everybody knows it, it's low cost to the business. You can use that to apply it to your career. For the most part, anybody knows how to configure stuff, which is why it's typically low paid. But almost nobody knows how to design things to optimize business performance, which is why architecture careers are highly paid. And most people don't know how to sell $1 billion technology plan, which is why you'll find really high paid cloud salespeople and networking salespeople. So always look at supply and demand curves. The businesses do when they choose their technology as well. So let's talk about designing for Azure Cosmos and DB and table storage. Remember, 98% of organizations are multi-cloud. So using things like AWS DynamoDB or Azure Cosmos or Google Cloud Bigtable really are not going to be a good option in 98% of enterprise businesses. But it's a certification exam, so we got to talk about it. So Azure Cosmos DB is a fully managed NoSQL database service. And Azure Table Storage is a traditional table storage for structured data. When we think about Cosmos DB, we want to think that it's fully managed. That means we're not managing servers, we're not patching the database, we're not updating the database, and they manage it for us. Autoscales out when we need it, autoscales in when we need it. And they say the performance is single digit millisecond response times. That's not exactly fast, but it's not horrible. When you're dealing with the cloud, getting that, because the way cloud providers are oversubscribed, that's pretty good. That's why you may notice systems that are off the cloud offer much more faster and more responsive when you go to a website, and when they're on the cloud, they're a little slower. There's that extra latency. But the point here is it's going to scale and it's going to be done for you. We can also think about migration capabilities. So if we've got an application that's written for Azure Table Storage, we can easily migrate it to Azure Cosmos DB with a table API with almost no code changes, or at least minimal code changes. And that provides a shared table data model with identical create, delete, update, and query type operations. So, we have graphics that Alonzo from my team put together for this. I'm not really one much to actually talk off of slides. I typically write little what I call chicken notes that says discuss this. But when it comes to something that's hard to differentiate between two, I like to have somebody from my team come up with it. And Alonzo from my team really knows how to make things beautiful. He's a great architect, but he also has a deep understanding of graphics. So if we think of table storage, it's fast, but there's no guaranteed limits or latency. Where we're dealing with Azure Cosmos, read and writes is less than 10 milliseconds, which is not fast, but it's not slow either. So kind of keep that in the back of your mind. With Azure Table, we got all kinds of different kind of throughput. And when we're dealing with Azure Cosmos, it tends to scale well. We can reserve throughput. We can get an SLA on it. And there's kind of that no upper limit, meaning it's going to scale. When we look at table storage, it's going to be there, realistically speaking, for a single region. And maybe we can post it to an additional region for geographic purposes. Whereas by comparison, when we deal with Azure Cosmos, this NoSQL database is everywhere in all the regions. So when we deal with table storage, we've got a primary key here. Now, when we're dealing with indexes, we can get much more automated indexing. We've got a lot more things that we can actually do to scale it out better on Azure Cosmos. You can see that Azure Table Storage is basically consistent inside of a region. But when we deal with the NoSQL databases, we typically have a slightly lower consistently, meaning we may write to one database and it may take a couple of seconds or a millisecond to get to the others. That flexibility there is going to enable these systems to slow. With table storage is how much you use, kind of like that serverless. You're just going to pay on what you use. Where what we're dealing here with Cosmos is we can basically pay on what we use, or we can guarantee and reserve something and plan for it ahead of time. And they both have, what you would call moderate availability. You get pretty good availability from table storage at 99.9. You get that same availability for a single region. And if you go to multi-region, the cloud providers say they can get to 99.999% availability. I'm not sure if any of the cloud providers, AWS, Azure, or Google, have been able to deliver 99.999% availability to any customer in the last few years. Because, things happen, and, it's not going to be the easiest thing to try to do it. There's just too many things to go wrong in a multi-tenant environment like a cloud provider. So let's talk a little bit about designing a data integration solution with Azure Data Factory. Here's the point. It's a cloud-based data integration service, and we can use it to schedule data-driven workflows. The functionality of Azure Data Factory is it's going to help orchestrate your data movement and between systems, and it's going to be able to transform your data at scale. It's like using an extraction, translation, and loading tool. So it'll extract your information, it'll transform your data, and it'll load it. Sorry, to me, it's actually transformation, but in my mind, it's translation, making one thing go to another. But that's really what we're talking about. So, what do we have to think about in an Azure Data Factory workflow? Well, the first thing was we need to ingest the data or collect the data. We connect it and then we collect it. So we got to connect it and collect it from the various sources we want, and we pull it into that centralized centralized location. Then we have to take that data and we have to transform it. And maybe we use Azure Databricks or Azure HD Insight Hadoop, or we just use traditional Hadoop or other tools to try to do that. And in a perfect world, we can pop it into a CI/CD pipeline, that continuous integration and delivery, and then we can publish it if we desire. And then we can use various tools to monitor things. We can use the Azure Pool to monitor pipeline activities, detect failures, what have you. So we'll briefly talk about the components of it a little more. So we're going to have pipelines and activities. And a pipeline is going to be a logical grouping of activities that are going to be performing tasks. And an activity is going to be a single processing step in a pipeline that's going to support that data movement, support that transformation, and control activities. And the data set itself is what we're really talking about is the data structures and the data stores. And we talked about link services. And your question popped in, and I just said I don't have slides that have anything other than Mike's chicken notes that might say, talk about a data pipeline. And I have no slides to clarify because of that. And only when I have slides that are worthy of sharing, I do share them for you. And that's because I had someone from my team make it. Hope that actually makes sense there. So let's talk about some other components of Azure Data Factory. Data flows. The purpose here is to develop a data transformation logic. So you're not out there writing code, to make it simpler. And we also talk about that integration runtime or compute infrastructure that needs to go in it. And we can have, say, an Azure self-hosted environment here or an Azure managed native SQL Server integration. The goal here is to bridge between activities and link services. I'm going to let you know right now that I am in Florida, and it sounds like there is a hurricane going on outside of my house. So hopefully my internet connection should be good. It's quite possible one of my internet connections goes down, and it'll take BGP about 60 seconds to 90 seconds to converge around my new internet service, my other location. So if that happens, I'll let you know. And Chris from my team will take over, and I'll be back in about a minute, unless the entire power to my home goes out, in which case that's a totally different situation. So when you're working with an architecture, let's talk about the things that you need to consider with Azure Data Factory. We have to really think about what are our data requirements needs. So what is it going to be? We make this concept of the community where we're going to support big data and relational data. We're going to have to think about these pipelines. We have to set up pipelines to access our data on our cloud, on our premises to get it. And when we're dealing with Azure Data Factory, the trend is making it that we don't need to code, or AI can do the code. And that's going to minimize an organization's burden of the need to hire developers. The whole point of this cloud computing is to simplify things. We're going to pay a lot more for the simplicity. So, they've got a graphical interface, and pretty much you can use a low code or no code authoring and monitoring. And that's one of the points of this tool, if you're going to use it. Although multi-cloud, there might be better tools to use. So let's think about support for multiple data sources, and Azure Data Factory can connect to a wide variety of data sources. So there is that. And when we think about Azure Data Factory, it's serverless. So it eliminates that need to think about your servers, your server operating systems, patching these systems, maintaining them, and configure them. And when it's serverless, you don't have to think about server capacity. I'm not saying that server capacity is the right thing, but or serverless is the right or isn't, that's going to be based upon the business and its actual needs. But I hope this kind of makes sense. Let's talk about data integration with Azure Data Lake. So, what is a data lake? Where we're pulling all of our information from various sources, right? And we're going to pull it out of our relational databases. We're going to pull it into, what's the word I'm looking for? We're going to pull it from NoSQL databases. We're going to be pulling it from data warehouses, those types of things. And we're going to potentially pull it out of object storage. There's going to be a mapping and reduction process to try and normalize that data. And then the data will be cataloged. So that's how you normally build it. But, Azure's got its own data lake type environment that may or may not be right for your organization. Of course, you can, in a big data environment, most organizations are going to have their big data architects and their big data engineers do that. Architects design and obviously engineers build it. And it's typically going to use blob storage, so that means it's going to use blob. And the reason object storage, and the reason it's going to use blob is as follows. Object storage has metadata, and that metadata is what it makes it integrate so well into big data environments. So let's talk about data storage. We're going to be able to store any data in a data lake because that's the whole point of a data lake. We can store it structured, semi-structured, unstructured, huge amounts of data. And when we're dealing with Azure Data Lake, it's designed to work with these big data frameworks like Hadoop frameworks or Hadoop file systems. It's going to give us fairly good throughput because it's object storage. And when we think of Azure Data Lake, we can obviously provide any of the IAM role-based access control type things. We can use replication models, so we can take the data in our data lake and maybe replicate it to another region. We've got massive storage, and that's one of the things that the cloud providers do provide is this massive storage capacity. And realistically speaking, it's going to be priced based on Azure Blob. So what goes into this Azure Data Lake? So first thing is we have to ingest the data. So, where is it coming from? Is it coming from relational databases, NoSQL databases, data warehouses? Is it coming in from streaming data, which it could be? And we can use tools like Apache Storm or Azure HD Insights or Stream Analytics. We're going to pull stored data as well. And with that, we've got the Azure Storage Explorer, which can help us with a graphical interface. We can reach in other tools via things like PowerShell, Azure, or Hadoop file system command type lines, and we can kind of configure our access control. So, here's an environment where I had someone from my team make a slide to kind of compare these two type things because I thought it would actually help. And think of Blob as object storage, and we can store anything we want on it. And if we look at Azure Data Lake, it's still using Blob storage, but it's more for these large volumes of data. With Blob storage, it's going to be geographically redundant by default. It's a standard Blob storage. With Data Lake, it's more about manual configuring our data and replicating our data. Namespaces, when you're going to reach out to it, it's going to be a little different. You've got a little more hierarchy in the data lake as opposed to Blob, which is a flat namespace, which we talked about before. And realistically speaking, here's the major difference. We've got that Hadoop capabilities, which really fits into that big data framework with the data lake. And realistically speaking, it's going to be more native things when we're using Azure Blob. Security-wise, we have got much more granularity with the data lake because we're going to have more data and more normalized data, and it's going to be easier to mine through the data. So we need to lock it down a little more. With blob storage or object storage, we have a little less features and functionality there. We can't get quite as granular. So now let's briefly talk about actually, you know what? I think now's the time to see if there's any questions. I think I've gone for about 20 minutes or so, 25 minutes. So let's see if there's any questions that I can answer. Let me get my... What would I suggest for a traditional SSIS engineer? I'm not sure what that is. With so many more weekend pieces in the cloud, it becomes much more than writing some tasks. So I don't know what an SSIS engineer is. So maybe, David, you could tell me what an SSIS engineer is. Maybe spell it out. Maybe you're using an acronym of some kind. And maybe we'll go to another one of the questions in the meantime, and I can answer it. If you're talking about a sales engineer, it's going to be a different one, but maybe let me know what you actually mean. Because I just don't know what you mean by SSIS engineer. Maybe it's something else. I'll go see if I can Google it in the meantime to see if it's some kind of acronym that I don't know what it is. You might be talking about a SQL Server integration service, but I'm not really sure. That's one of the dangers with acronyms, which is why I teach, which is why when it matters, we tend not to use them. And that's why medical people are taught not to use acronyms, because people can actually get hurt or die. If you use an acronym, it can have many meanings to different people. It's the same reason architects, generally speaking, are not allowed to use acronyms when they speak to their clients, because there's a confusion area. So SQL Service Integration Service. So what would I suggest for a SQL Service Integration Services engineer? Well, that's a really great question. Well, actually, the person that actually answered it is not the person that actually wrote it. So I still don't know what the answer is. Phil or Ash, what you're actually doing there is you're making a hypothesis what this person meant. And without clarification, we really don't know. And that's why, like a doctor, if they're going to ask a patient a question and somebody else would answer, we don't know what it's really. So I don't know what David Parker actually meant. But if I had someone that was focused,
All right. Well, there is that internet issue that Mike was expecting due to his weather. I'm sure his BGP is kicking in, and like you said, it usually takes about 60 seconds to switch over there. So hopefully he'll be back with us in a moment. And okay, so David did confirm SQL Service Integration Services. So when Mike gets back, we'll make sure that he answers that. Now that we're 100% certain that that's what you were referring to. So just in case, I don't know if you can hear me. If you can hear me, let me know in the chat box, because I'm usually the one that's telling Mike that we can hear you. But since I don't have anyone here to tell me that they can hear me, maybe you're just listening or watching me just talk randomly to you. So, yeah, all right. Looks like all of us in Florida are getting hit by this. Okay. All right. So let's see here. Yes, VJ, yes, we did lose Mike. Cantor, Data Lake is where the AI applications. Perfect. Well, great. I'm going to be saving these questions for as soon as Mike gets back. Okay, great. So everybody can hear me, but I'm not the person that you want to be hearing. So anyway, while we're waiting on Mike to come back, I do want to, I guess I'll do my bit here. You know, we've got the lab demos. I got the banner up there. For those of you that haven't already gotten the lab demonstrations, we've got about 30 or so lab demonstration videos for you to go through and just and follow along with and do yourself. It's not a sandbox environment. These are videos that you then have to go and you actually do it in the real environment, and you get to play around with it. So let me put this link in here for you all, and then we'll get. I think I got Mike back here, so we will bring Mike back in. All right, there's Mike. Mike in a little box down there. There's Mike. So also
Hey, everybody.
apparently, Mike, Mark got taken out at the same time that you got taken out. So,
and we're separated by about 150 miles, actually.
Yeah.
So that's interesting.
Yeah.
Like I said, it felt like there was a real hurricane out there, and that's why you never deal with one internet service provider. I have a Verizon device and an AT&T device, and that way, when either provider goes down, I'm still up. But it does take some time to converge around it.
All right. So while you were gone, David did confirm that he was talking about the SQL Server integration services. So now that we've got that clarification, we can answer his question. Have you address his question? So here's his original question for you, and I will disappear.
So, David, you asked two kinds of questions. If you're asking for real what I would do if I was a SQL Service integration engineer with more places that are now writing code and doing things differently in the cloud, I would ask you first thing I would say, suggest this. I would try to go out of that engineering environment and move more into a data architect environment. And I'll tell you why. A lot of these back-end manual processes, a lot of this integration work can actually be done by AI. And we're seeing lots of organizations right now, IBM, and even Cisco just did a layoff, and they're immediately hiring people in that sales role, in these pre-sales role, days after these big layoffs. So these back-end roles are being automated, or they're being offshored to the lowest cost parts of the world. So I would try to get out of that from a career perspective. So there is that. Now, if I was going to be doing something like this, I would not be focusing on SQL Server. I'd be focusing on data and big data. And what do I mean by that? So at the end of the day, the hands-on, how you actually configure this stuff or do the integration, that's a skill that you have to compete with the entire world. And David, and I mean this in the most respectful way because I care. A lot of people are refusing to go back to the office when the companies are asking them. I'm not here to say remote work is good or bad. I've been remote for 20 years and I love it. But one of the things I can tell you is if you're going to work remote and the workers are not going to come into the office, there's no reason to have somebody that lives in California that has to be paid a California wage work remotely. I can easily hire someone really great in, say, Lagos, Nigeria, or Cape Town, South Africa, or Karachi, Pakistan, or Bangalore, India, places where I'm going to get a lower cost. So I would try to get out of something like that, and I would tend to move into something like big data. And if I was going to be an architect, big data architect, that's going to be an easy thing. There's lots of jobs. If I was going to take my data background and move into an AI architect role, it would be a good job. But if I was going to be on this data side, I would get much bigger. I would get out of that just writing some tasks, and I would focus on, if I was going to be on engineering, on data. So really focusing on, being able to take the streaming data and do something with it with a level of expertise. Being really good at understanding how to take the databases and the creation of data lakes and that mapping and reduction type functionality. And that data lakes and the data cataloging and then running machine learning on it to make inferences from the data. So I would try to move myself up. And by doing so, you're going to be safe. So I've been through about 20 layoffs in my life, and I've never been laid off once. And when I work with people and they ask questions like this, I try to say, go from this into something much bigger. More workloads are running on Linux, which means Microsoft SQL Server is not really going to be one of the primary things. So that's what I would do. Again, it's not that I don't love people that do this. I do. I just look at more macroeconomic forces that are out there. I look at the challenges that business are having, and I look at the technology that's out there, and I look at what is that of the implication on the people that are doing it. And that's why I say what I say. I hope that helps, and I hope it makes sense. You completely respect the background that you have and all the skills that you have. I just don't want to see you ever have to get displaced because of what businesses are trying to do and what the technology platforms are taking us there. That's why a lot of networking people like me started migrating to the cloud because we still need networking on the cloud, but we saw it as where the future is going to be, and we didn't want to get left behind. I hope that helps, and I really care, and that's why I'm saying that. Data lake is where the AI applications access the training data. So it could be. So generally speaking, a data lake is often used to storage large amounts of structured and unstructured data. And many times this is training data for your AI applications. And by taking our information out of our relational databases and out of our data warehouses and out of our NoSQL databases and out of object storage, and catalyzing that data, cleaning up that data, normalizing that data, it often becomes a very scalable and cost-effective means to train our AI models. Now, there are obviously other forms of data that we could use to train our AI models, but it is a very good opportunity for us to use AI. But we could be using databases as our training data. We could be using file storage as our training data. But very frequently, data lakes provide a very good opportunity because what do we have to do in the creation of data lake? We have to normalize that data and create some data hygiene. So here's what I mean by normalizing data. You may have Mike Gibbs spelled M, capital I, capital K, capital E, and Gibbs all spelled capital. Then the next one, you may have Mike Gibbs with all lowercase letters. Then in the next one, you may have capital M and then IKE lowercase and capital G and lowercase IBBS. And that could all be me. And, sometimes you sign up for something, it's late at night, but your wife wants you to order something for her and you're exhausted and you just use all lowercase because you're just tired and you get that. The next day you got the caps lock, but you're too busy and you don't care. So these are the ways businesses they've got this data. So we have to look at data anomalies and things that are wrong and throw it out. We have to normalize our data on the way to the data lake. So that kind of data normalization and data hygiene and a lot of those things actually makes that data lake often a very good place, either for machine learning environments to be able to make inferences from our data, meaning where we're analyzing data. It could be one of the many sources that we would use for training data for a generative AI application. That's a great question there, Ken and Grant. All right. Well, let's get back to the content. So if you just joined us new, we have all kinds of hands-on work for you to do at Azure. And you can get them completely free. You can sign up our website for these free Azure Lab demonstrations. In the description of this video, we have a whole host of free resources to help you with your interview, documents on the skills to become a cloud architect, documents on the skills to become an AI architect, so many things. Which certification should you use for what? They're all free, so go get them. And of course, weekly we have a how to get your first cloud job webinar or architect job webinar. And sometimes we talk about enterprise architect roles. Sometimes we talk about cloud architect roles. Sometimes me and David Lithicum talk about AI architect roles, but they're all free and we run these each week. So let's briefly talk about Azure Synapse Analytics. And of course, give me a hashtag AZ305 so I know you are actually awake. So what is Azure Synapse Analytics? It's basically a big data analytics platform, an enterprise data storage platform, and a data integration platform. And the point with Azure Synapse Analytics, the goal here is to perform a data injection, maybe explore our data, transform our data, whether it's going into another database or a data lake, be able to manage our data and be able to look at our data with business intelligence tools like Tableau or Power BI to really see if we're getting anything there that's going to show us that there's something going on with the data. or something that we can actually use. So that's one of the reasons we're realistically using these types of services. Bear with me a second. And if we think about Azure Synapse Analytics, we're dealing with big data. So if you've got a lot of data and you've got to do something with it, you're going to need a lot of compute power, like a lot of it. And typically speaking, this means parallel processing. So parallel processing is kind of if you had 10 GPUs in a machine and you test it to various CUDA cores on each GPU, if you're using NVIDIA, you may have thousands of these little processors, these CUDA processors on a GPU, and you may have 10 GPUs inside of something. So what's going to go into the architecture of this Synapse Analytics? Well, and it goes to anything. We're going to need a control plane that orchestrates it, right? And then we're going to need a data plane or something that does the work. So Azure calls the control plane the control node. And that's basically the brain of the solution that's basically going to be there. So the compute node is going to be the data plane that actually does the work, the computational power. So let's talk about what goes into Azure Synapse Analytics. The first thing we have is we're going to have this Azure Synapse SQL pool. And usually speaking, that's going to be a serverless or a dedicated resource model. The plane here is we're going to have predictable performance with what we're coming up. Now, whenever we're dealing with data processing, these type of things, you typically think Azure Spark, PySpark, or Apache Spark, right? So, what's going to go into this is the Azure Synapse Spark pool. And what is it? It's a group of servers running Apache Spark for data processing. So that means whoever's doing your coding, they can write these tools in Python or Scala or SQL or C#. Now we still need to create this pipeline. Basically, this extraction, translation, loading, and data integration service. So Azure has that Azure Synapse pipeline. And the point here is to create an event-driven workflow. So we can take our data, we can orchestrate the movement of it through the system, and then be able to do something with it. That's really what we're talking about with Azure Synapse Analytics. Now, I had Alonzo because we talked about Azure Data Factory, and we also talked about Azure Synapse Analytics, kind of come up with a compare and contrast document for it. So with Data Factory, the point is we're dealing with data and we're going to be sharing it in many cases. We're not going to do that with Synapse Analytics. With Synapse Analytics, what we're really going to be doing is working within the Synapse environment. And it's going to give us Apache Spark and these types of tools that we can actually use. By comparison with Data Factory, it's going to be more integrated with the various Azure tool sets, more templates that we're dealing with, and it's less of more of the streaming data and type environment and less of an analytic service. So I kind of hope that helps. It's a little tricky when you hear all these things with the word data. So that's why I had Alonzo kind of draw these diagrams for us. Now, we have the concept of a hot data path, a warm data path, and a cool data path. So we'll talk a little bit about these, but realistically, it's all going to be based on how frequently the data is accessed. And if you're going to access it all the time, it's going to be hot data. If you're going to access it a little bit, it'll be warm, and it's going to be cold. It's going to be stuff we don't access that much, and that's going to reduce the cost of what we're using here. So let's think about it. With on-premise storage, that's going to be traditional storage. We don't have to worry about life cycle, and here's why. It's cheap. In our data center, it's very cheap. When we go to the cloud, we've got to pay a fortune to store our data compared to what it was locally. So here's where we need these life cycle policies where we don't store our data in hot and we put it in other paths and we get a reduced price to store it, and then we typically pay to actually access the data. So let's think about this hot data and when we use it. Well, that's real-time processing or displaying of data. What if we're getting clickstream data from the website or a bunch of data from IoT systems? That's streaming data. This is also real-time data. We want to get data and we want to do something about it in real time. And it's going to be very latency sensitive. The data is going to need it. We're going to get access to it, and we want to do something about it. That's your hot data path. By comparison, a warm data path is going to be more about analyzing data. It's going to flow through your system. We may use Azure Stream Analytics. The point here is we're going to be taking in various streams, and we're going to try to store it in maybe an Azure SQL database or a Cosmos DB. And our cold data path is going to be long-term views and analysis, historical analysis. And historical data is great. What were your sales for the last 5 years? What were your pricing strategies? What were you kind of doing? So keep that in the back of your mind. Now it's sounding even more like a hurricane outside. I can't tell if you can hear it through the chat or through my microphone if it's letting it come through. Hopefully I don't lose my second internet service provider or my primary one came back on. Now, when we're dealing with this cold storage, when we think about where we might put it, we might store it on Azure Blobs, maybe in Azure Data Lake, Azure Files, queue storage tables. And with unstructured data, obviously, we're going to start in blob storage or file storage or data lakes. And we may use this to store original unprocessed data from, say, IoT applications. Think about it. You got all these IoT-enabled weather sensors from all over the world. And it enables you to run a historical calculation and see, what the hurricane season might look like with various weather patterns, El Nino, La Nina, and other atmospheric conditions, maybe make better predictions. That's why we're dealing with all this data. So Azure Stream Analytics, remember, it's a platform as a service. So there's you basically you're just putting your code up there. And the point here is to provide a real-time analytics service that you don't have to think that much about or know that much about from sources of streaming data, weather sensors, click streams, social media feeds, IoT type devices. So when it comes into the stream analytics, let's talk about the various components. We've got the streams, right? IoT, sensors, what have you. And then we have to process it, which means we have to consume this data and analyze these data streams. Because if we don't analyze it as raw data, and that's generally meaningless to we humans. So if a car goes through a toll booth, maybe we want some information about it with a timestamp, what have you. And then obviously we have to ingest this data. So there's lots of ways we can do it. If we want to go with a standard environment, like streaming data, we can use something like Apache Kafka, where we manage our own servers. And that Apache Kafka will work on all clouds, which is why it's so popular. But we can use Event Hub or Azure IoT Hub, what have you. And then we're going to look at our data. So typically speaking, we're going to use some form of an SQL query language to look at our data. And we're going to do that because it's going to enable us to be able to look for what we're looking for. And obviously, we need to think about where the data is coming from. So what are we doing it? Where's it coming in from? Where are we going to output it to? And that query, we hope, is typically based on SQL or something that most people need to understand. Now, when we output this data, where are we going to put it? Well, we can put it in a NoSQL database like Apache Cassandra or Azure Cosmos. We can put it in a relational database like Azure SQL database or MySQL or something else if we wanted to, or Oracle's database. We can put it in Azure Blob. Now, when we've got this real-time data, we can look at it and evaluate it. A Microsoft tool would be Power BI. That's going to give us a visual representation of the data. We can also send our information to a data warehouse like Postgres, which we could use, or a proprietary version that Azure has. And we can trigger some custom workflows. Right? I've got this data. What do we want? A serverless function like an Azure function, a bus topic. We can put it in a queue. Where are we going to send it? So when we think about setting up these stream analytics type solutions, we first have to think about what do we need. If we use Stream Analytics, it's already there. So we don't have to think about provisioning hardware or infrastructure. And what's nice about this is we can focus on the business logic as opposed to the infrastructure. But you lose control when you go platform as a service. So, all these things kind of are needed to think about. So what other things should we think about? We need to think about how it's going to be implemented. And we architects, whether we're cloud architect, solution architect, enterprise architect, AI architect, we're never going to implement anything, but somebody would be. And what realistically we need to do here is as follows. We need to think about who's actually going to implement it and what's going to be necessary. Do they need something low latency where we should basically use IoT on the edge? Or are we going to use something like Azure Stack? And we need to think about the performance and the performance guarantees, what have you. Because we can potentially be dealing with millions of these events per second at low latency. And Stream Analytics, thankfully, can handle that. So when it comes to security, we want to make sure that we encrypt everything. Azure Stream Analytics supports TLS version 1.2. It's got built-in encrypted checkpoints. And it basically can process it in DRAM or in memory. So you don't have to store it if you don't want to, because this is real time. So we also need to think about what our workloads might be. For high performance computing applications, consider batch or virtual machines. So it all comes down to it. We need good compute capacity. When we need good performance, we're always going to go back to infrastructure as a service virtual machine, because we can have more capacity, more CPU, more DRAM, and we can control it. But then it's going to be up to us to make sure we have it. Of course, we can use Azure Batch as well. So that's giving us the thought, what kind of compute service we typically need. So when it comes to compute, we need to think about what we're using. Platform services basically are there. We upload our code. And that might be great for web applications, mobile applications, APIs. If it matters, we're going to use infrastructure as a service, like virtual machines, because we've got full control and containerization. And if we're dealing with something that's event-driven, we could still use a virtual machine. But if it's not going to run that often, again, what we're going to realistically do is basically focus on the Azure function itself, or a logic app where we can run code without thinking of the infrastructure. Now, when we pick a compute service, we have to think about what we need. We're going to the data center to the cloud. If we do just a lift and shift, if we take our virtual machine from the data center and migrate it to the virtual machine in the cloud, and this is 50% of migrations, all we did was took a virtual machine in the data center and moved it to the cloud, and now we're paying 3 to 5 times more for the identical service that we already had in our data center. Not a lot of transformation. Now, it still might make sense if an organization has an old, dilapidated data center, or they don't have the people. Maybe they can't hire good enough people to actually run their data centers, what have you. So think about that. That's the lift and shift. Now, if we're going to cloud optimize our systems, that might mean we have to refactor our applications to take care of the cloud native features. Things like, which of course we can do Kubernetes in our data center or the cloud, but there's a refactoring. And we have to factor in the cost of refactoring. Does it make sense? And when we refactor applications, we have to think about it. Everybody was refactoring the microservices, but that kind of stopped. Why did it stop? Because, if we have a tremendous number of developers, microservice makes sense because lots of people, like thousands of them, like Google, can be working on different things. If we have got reused service patterns and reused lines of code, microservices make sense. But if that's not the case, we're typically better speaking with a monolith, which means don't cloud optimize, go back to that virtual machine. So it's knowing your business and knowing your use cases and not having any preference for a technology. What if we've got a containerized application in the data center? Guess what? We can just move that container to the cloud in a lift and shift environment, just like we actually did for a virtual machine. Or maybe when we migrate to the cloud, we take our application that sits on a virtual machine and containerize it and then move it to the cloud in a container. The key is what are we trying to do? So if you think about it this, when we think about how we're going to host our applications, Infrastructure as a service is a virtual version in the cloud of everything we had in the data center. It's just that the data center is better, faster, and cheaper. No, but it's the same thing. And the data center is better because you've got more control, and the cloud providers oversubscribe their systems, and you own in your data centers. You typically get better and less latency for the WAN, and better networking too. So infrastructure as a service, your data center will give you better performance there. It's typically cheaper. It was interesting when some of the members of our team looked at AWS. What we did is we took a Dell server with about 192 cores and about 4 terabytes of DRAM and a huge RAID array. It was about $300,000, so it wasn't cheap. And we priced it out to use that, and we chopped it up into virtual machines on AWS. And over the course of 4 years, that $300,000 server was $6 million to run in the cloud. So, it's cheaper, typically speaking, if you've got the people, the knowledge, the know-how, the sophistication in that data center. And it's typically faster performance-wise in your data center. But in your data center, you have to have the capacity. The speed and agility of launching these virtual machines on the cloud is fast. I can launch 1,000 virtual machines, or I should say a DevOps engineer can launch 1,000 virtual machines in seconds on the cloud. Now, they could do the same Terraform script with an OpenStack or Nutanix cloud in your data center, but you'd have to have that capacity. And if you don't have that capacity, you have to go to Dell or HP or Lenovo or IBM or somebody to go buy your service. That's where the cloud's faster and more agile. But if we're doing infrastructure, that means we have to manage everything. The operating systems, the data, the applications. We've got to manage the infrastructure, the networking, the storage. It's basically we're just using a virtual data center with slower performance and higher cost, but better agility. Now, by comparison, if we're using platform as a service, and Alonzo drew me a beautiful graphic here that I'd like to share. Basically, what you're doing is you're just giving your applications to them. And whether it's a function, your data, your applications, that's all you put there. But all that underlying technology, your virtual machines, their operating system, a container runtime module using a containerized application, it's all done for you. So it's pretty much just upload your stuff and go. And when it comes to a function as a service, that gets us into the super simple area of somebody just writes a little code, like you set something you put it in Blob or object storage, you set the permissions wrong, and then poof, one of your logging notifications hits something, kicks off an Azure function, and immediately remediates your bad permissions so you don't get hacked. That's where these little functions kind of become really impressive. So if you think about who does what, in the infrastructure environment, you're planning your networking, you're planning your storage, you're looking at your virtual machines and determining their capacity, what you need, what you don't need. That means the team of people are going to be doing that. The cloud provider provides the underlying infrastructure, their routers, their switches, their physical load balancers. The hypervisors on their virtual machines, that's what they're going to be managing. So it comes down to control, and it comes down to the performance that you need. So infrastructure as a service, full control, which means you got to do more work. So I like to view infrastructure as a service as going to my mother-in-law's house for dinner. My mother-in-law has been taught to cook since she was like a little child. In Greeks, everybody takes pride in their cooking, and she did that. She must have read 5,000 cookbooks, and she spends 4 to 6 hours a day, and I'm not joking, watching cooking shows. Say she's the best chef for the family. That's infrastructure as a service. Why? If I tell her that I want broccoli cooked a certain way and a steak cooked a certain way, it's done. And it's perfect. But I've got full control over it. Platform as a service is kind of like if I go to Burger King or McDonald's, which I haven't done in decades. But if I were to do that and I were at a Big Mac, fries, and a Coke, which I wouldn't order because I don't eat sugar, I don't eat fried anything, and I don't eat white flour. But, here's the thing. That's platform as a service. You lose that control, but it's quick, it's easy, and it's simple. And The function as a service basically is just a little mini code and it's all managed. You've got the least control. So let's actually think about, when we, why we do this. So it's all based upon what the business actually needs. Do we need to maximize our performance? Well, then you can't leave it up to chance. You need infrastructure as a service. Do you need max capacity? Infrastructure as a service. Are looking for something more simple and easy with less overhead? That's your platform as a service. And our serverless functions are basically something quick and dirty and to the point. So when you deal with these things, you really have to go through something. You have to determine if you're migrating an existing application or building a new one. And if you migrate what you have, it's a lot less development costs. But is that the right thing? I don't know. The only way you're going to know is you're going to evaluate that business. You're going to evaluate that business goals. You're going to evaluate that business needs. You're going to evaluate the way the users use that technology. And is it getting the business to its goal? If it is, leave it alone. Don't touch it. If it's not, create something new that's going to get that business to its goal. Now, when we migrate our applications, if we decide to migrate them, do we move them as is or do we refactor them? Again, that's going to depend on how they're used and the type of ability. If it's a big, powerful application that we need, run it on a virtual machine and lift and shift it. If we've got a virtual machine and when we look at our applications, you've got like 10 components of our monolithic application, and 9 of those components are doing absolutely nothing all the time. They're operating at 2%. And we've got one component of that application that's operating at 85% that's causing us to run out of servers. Then maybe we optimize it to a more microservice-based application and use more cloud-native features. But we don't know until we run that analysis. And that's how you can find an architect that knows something. Somebody walks in the room and says, microservices, that person gets outsourced and you need microservices. That person's literally walked out of the door with security because they're biased, and you can't have a bias in architecture. Could you go to a doctor that said, you need Pfizer pills? Well, what if Eli Lilly makes the right medication? No, you can't take it. You need Pfizer pills. So that's like ridiculous. Your doctor has to be trustworthy. And the architect, when you're going in there and recommendations, you need to be trustworthy. So think about it. Full control, virtual machine. High performance, generally speaking, virtual machine or Azure Batch. Microservice, maybe use some form of Kubernetes for your containers. Event-driven, use a serverless function. Think about that, and that's kind of going to help you. Let's talk about some more about some virtual machines. So when you deal with your virtual machines, what are you really thinking about? Well, the first thing you need is CPU and DRAM. And then you need to think about your networking, your IP addressing plan that's going to be used. You're going to need something that's going to scale, something that can be summarized IP addresses. And Chris, please drop a video where Mark and I talk about subnetting and supernetting and route aggregation, that free webinar that we did. Please drop that in there. Because if we get that wrong, everything falls apart. Now, when we use virtual machines, I don't know how many of you have actually looked in systems that nobody named properly, and you go and you try to figure out what you have. Well, I've got to tell you, I've been a lead architect with customers that have 5,000 and 10,000 routers, and nobody decided to put names on them, and the documentation was bad, and there were like 30 and 40,000 servers, and you couldn't even find them. And I had to bring in a team of engineers to literally go through the systems and hop from router to router and then try and look at what was plugged into them. Now, if you've got a naming convention, that'll make it easier. So use meaningful names for your systems. Maybe Palm Beach, Florida web server, but something that's going to help you figure it out. But make sure it's a consistent naming convention. And when you're putting your virtual machines there, think about, not all availability zones have the same hardware. They don't always charge the same prices in the same parts of the world. Get your technology closer to where your users need it from a performance perspective. because they'll have reduced thing. Now, it comes down to it. Every cloud provider has these meaningless marketing terms that they actually use these. And general purpose generally means balanced CPU to memory ratio. I have no idea what that means. And why do I have no idea? We deal with CPU cores, the frequency of those cores, and the DRAM. And I'm not going to just look and pull something off general purpose. It's ridiculous. I'm going to go look at what those servers are. Because a 2 gigahertz server from Intel versus a AMD EPYC processor core that's modern don't perform the same way. And I need to know what I'm using and what's going to work for my client. So I look at CPU and DRAM. Every architect does. This is a certification exam. So general purpose means CPU to memory ratio that's balanced. And they say testing or small databases. Compute optimized basically means designed for higher CPU computation with lower memory. Okay. High CPU to memory ratio. Again, all I care is CPU cores and DRAM and network performance and disk performance. The rest of this is marketing fluff, but understand compute optimized, that's what it means. So they would tell you to use it for application servers and batch processing on an exam. Memory optimized means lots of memory compared to CPU. So when would you use lots of DRAM? Well, maybe for a caching server like a Redis cache, maybe for something that's doing a lot of in-memory analytics. You may have a relational database that you need this for. Storage optimized is going to be high disk throughput and I/O. Maybe use that for databases. Now here, when they say GPU, there actually is something. And what is a GPU optimized virtual machine? Well, generally speaking, a virtual machine has got it's got software-based drivers for everything. And if you actually needed some important thing, like better performance, like you may hear in networking where they have single root I/O virtualization, where they push a physical network card into a virtual machine through PCI pass-through technology. So you get a hardware card versus a virtual card. Well, in a GPU optimized instance, it uses a technology called PCI pass-through, where your hypervisor allows you to push certain hardware into the virtual machine. So that way your virtual machine can have a GPU or multiple GPUs in it. So when using any kind of GPU instance, you're dealing with a virtual machine that's got a hardware GPU sitting in the virtual machine. So machine learning, deep learning, graphics rendering, video editing. And high performance compute is basically going to be a modern server that's got good performance. So when you think about virtual machines, we need to think about their pricing. They're billed basically per minute based upon the virtual machine size and the operating system. Storage costs are going to be billed separately, and you only pay for these systems when you use them. Regarding Azure storage, Azure Managed Disk are going to handle a lot of the storage. So when it's dealing with this, you're going to specify your disk and your performance tier. Do you want standard? Do you want premium? And of course, it's block storage, and you don't manage that. Azure actually manages those underlying RAID arrays, for example. And when it comes to the operating system, you've got various operating system images there. And normally in the data center, what you actually do is normally what you're actually dealing with is normally you would, in a data center, you would install your own operating system in a virtual machine. You'd make your golden image, and then you would do it. When you deal with the cloud providers, effectively what they do is they actually make their own golden images. Red Hat Enterprise Linux, this version. Ubuntu Linux, this version. And you just click a button and it starts. And if you need something that's got some customized purpose, what we're really talking about is like a firewall, or maybe you need a reverse proxy from F5. It's a special purpose tool that you can actually get from the Azure Marketplace. Now that's virtual machines. Now sometimes you're going to have some kind of large scale system that you need a lot of work. Now you can just use as many virtual machines as you want. Or you've got this concept of Azure Batch. And what is Azure Batch, and what is it really doing? It's an environment where you can have multiple servers that handle compute tasks efficiently. And the functionality here is that it manages a pool of compute nodes, and they're going to run them for you. So it's going to do lots of scaling. So, if we need it done on one server, that's not batch. Batch is for these high performance parallel processing workloads where we're going to get 1,000 servers or something crazy like that, 50 servers. And what happens is a batch will basically automatically start a pool of virtual machines. It will store the necessary applications and data that you told it to, and it will run these jobs until it's done, and it will close down. So it's great for either in these tightly coupled workloads or independent workloads, things that need parallel processing. Lots of task-to-task communication, like a Monte Carlo simulation or an image processing or a DNA type sequencing kind of thing. And we have to really think about that. And, that's what we're really talking about for these types of things. So what's the workflow with Azure Batch? Well, typically speaking, you have to upload your input files and your data and your application files to an Azure storage account. That's your repository with your inputs. Then basically what you do is you create the pool, the job, and the task. You define your pool saying, I need this many Windows or Linux systems. We create a job that's going to specify the workload, and we break it down into tasks. And then we tell the pool that it can be either dynamically scaled based on demand. We download our input files and our applications, and then we monitor it. We monitor, okay, it's 30% done, 40%, 50% done. When we're done, we upload the task output, and we download our output files, and we are done. So some things that we should think about when we deal with this is we should look at the pools. We don't want to create a new pool for each job. So we want to use pools dynamically, flexibility, and think about how to do it. Now, we also need to think about our nodes or the system, the VMs that are doing it. Individual nodes are not guaranteed to always be available. We don't want to allocate pools and nodes to see what works. And the jobs that we're going to do, we're going to have to give them various names. That's really what we're talking about. Okay, let's talk about Azure App Services. Chris, how long has it been since our last break? Okay, let's do some questions. Since the solution architect is different than a cloud architect, same with SA Pro. So a solutions architect and a cloud architect is the same job. The difference between the solutions architect and the cloud architect is the solution architect only works with one vendor. So if you're at Azure, you design, present, and sell Azure solutions. If you're a cloud architect, you design, present, and sell solutions off of every cloud provider and every vendor. So the solutions architect is like a junior cloud architect, but the job is the same. Nothing really changes in the job. We don't code, we don't configure, and even still, none of the certifications really have anything to do with the role. The Azure Solutions Architect training it has a lot more architecture in it than, say, the AWS Solutions Architect one, but still, you need to understand how to understand the business, how to understand the business processes, how to get to the business goals. Still, you're selling a solution, so that means building a business case, quantifying the problem, managing stakeholders, presenting to executives, negotiating deals, building architecture teams, leading architecture teams. But the difference is if you're at Cisco, you design, present, and sell Cisco stuff as a solution architect. Whereas if you're the end customer, nobody's going to just buy a single vendor anything for the most part. They're going to use, firewalls from Palo Alto, Fortinet, Checkpoint, Cisco. They're going to get some fancy load balancers from, say, F5. They're going to be dealing with unified communications, most likely from Cisco. They're going to be dealing with a conferencing platform, potentially from Microsoft or Cisco or Google. And that's just the reality of the world. So it's the same job, cloud architect and the solutions architect. It's just the solutions architect is more junior because they only focus on a single cloud. We go to the next one, Chris. When you migrate to the cloud and optimize resources and apps, isn't that better for the company than staying on premise and paying all the capital expenses? So here's the thing. Which is better for you? Well, first, capital expense versus operating expense. Which is better for you to buy a house for $500,000 and pay a mortgage that's $3,000 a month, or for you to rent that same house for $6,000 a month? So it all depends. If you're only going to be in that house for 1 year, it's much better for you to rent that house than it is to buy the house and pay the transaction cost of building it. So depending upon the organization's weighted average cost of capital and its cash flow determines whether it's better. In most cases, it's better to buy something than it is to have monthly payments for the rest of your life. So there's that. But you can build your data center in a completely operational expense manner too. So if you buy the equipment, meaning you call Dell and you finance it, or Cisco, that's capital expense. But if you call Cisco and say, I'd like to lease the gear, that's an operational expense better than the cloud. So I'd like you to think about it this way. If it costs you $10 million to build it, and you divide that over 4 years, and it costs you $2.5 million to run it, and if it costs you $5 million of rent every single year on the cloud, isn't it cheaper to do it in the data center and actually have the gear and have better performance? So we have to analyze all the facts. We've got to get access to all the information. We have to understand our usage pattern. Is it cheaper to rent a car? Is it cheaper to use Uber than buy a car or buy a car? Well, it depends. If you're in a place like Florida where you've got to drive 25 miles in every direction, you need to go somewhere, and you have to drive 3 times a day, you don't want to take Uber. It'll bankrupt you. But if you're in New York City and you walk everywhere and once a day you need to pay a $10 Uber ride, it's cheaper. So that is the business acumen. The reason people got hurt in the cloud and the reason we have what's called cloud repatriation is so many businesses leaving the cloud is somebody told them it was going to be cheaper. And it wasn't cheaper. And that's why you see so many businesses leaving the cloud. At the same time, we have so many businesses going to the cloud because there's certain things that the cloud can do. The agility of the cloud, the speed to market of the cloud is great. But there is no better OpEx or CapEx. That's basically saying, is it better to rent or own? It depends. It really depends. I can tell you one thing, the people that have the most wealth and typically don't ever rent anything, they buy things that appreciate. That's why a lot of rich people are real estate people. They bought the property. Often people with less money rent the property, and they don't get that appreciation. They don't get that opportunity to build wealth. If I need to run a GPU and it's $35,000 for me to buy that GPU from NVIDIA, OpEx, and I spend $35,000, isn't that cheaper than paying a cloud provider $45,000 a month for the next 4 years to rent that same GPU that I could buy one time for $35,000? So it'll cost you 60 times the price to run that one GPU in the cloud. This is why architecture has nothing to do with a certification. It's understanding that business and understanding its cost of capital and understanding its needs and building a business case after evaluating everything in the business's future goals. Will data that is cached or saved in the cloud have the same latency if it is on-premise to the data center? Does the cloud add latency? So we have higher latency in the cloud for 2 reasons. If I'm inside of my data center and I'm on campus and I want to access a system, I typically have to go through the routers and switches that are in my system. And typically that's 1 to 2 milliseconds or less. If I go to the cloud and I have to go from system to system, I have that same 1 to 2 milliseconds. Now, realistically speaking, on the cloud, it's going to be a little longer. And the reason is the cloud providers typically oversubscribe, meaning if they've got a network that needs a terabit a second if they've got users that could potentially use a terabit a second, they'll build for 1/10 of that, because statistically speaking, not all users will use the things at max capacity. In your data center, you typically oversubscribe less because it's your own business. One of the ways the cloud providers and internet service providers actually make money is they build less and they oversubscribe it. So that will add additional latency. Plus, when we get to the cloud, if our users are in a campus and we've got to connect to the cloud, we've got the wide area network. So we may have between me and the end system 1 to 2 milliseconds of latency in the data center. If we go to the cloud, we may have 3 milliseconds in their data centers because of the reasons we talked about. It may take me 5 milliseconds or 6 milliseconds or 10 milliseconds round trip time to actually get there. So we're going to have substantially greater latency in the cloud. And that's just because it's a wide area network. Now, Freedom Lands, it's no different than if I'm in New Jersey and I put my data center in Colorado and my users are in New Jersey, I'm still going to have that same latency. So it's not related to the cloud itself. And there was one really incredibly dangerous question here. And the dangerous question is when someone works with mentioned microservices, isn't it because they already understand the business and the benefits of decoupling for the scalability? No. Sadly, in most cases, the people that have done this are somebody that falls in love with the technology. I love microservices. They're exciting to me. Ooh, they're better. Now, what I want you to understand is, AWS is trying to say the mainframe is bad for you and we can do better. And you know why mainframe spending is going up? Because there's some things that the mainframe can do better than the cloud. So the mainframe, which we all thought was going to die 25 years ago, mainframe spending is going up because it does certain things well. So if somebody really understands the business, they understand that there is no best technology. Many of these companies went there because they thought that one technology was better. I've got to ask you a question, and I want you to think about it this way. Which is better for you and your needs? A giant truck or a race car? Let's say we've got a truck that's made by one of the best truck companies in the world and it can go 1,000,000 miles. By comparison, I have a Ferrari, which is a beautiful car that gives you high performance. Which is better? They're both the best technology. Which is better? Well, if you're going to be on a track and race, the Ferrari's better. If you've got to haul a large load, the truck is better. So a lot of times we have 70% of all technology projects are disasters because someone thought the tech was cool and exciting. When it comes to AI, 80% of these things have failed because the people that built it or designed it didn't understand the business. And that's why there's been such a move to these big architecture roles, because we can't let the tech people drive the business. The business people must drive the technology. What's the best pill? No, seriously. Imagine a doctor that had a preferred pill without actually understanding the patient's medical condition and making a diagnosis. That's what we're talking about architecture. It's the same job as the physician. It's the same job there. And now your question about can't we just use CloudFront or Global Accelerator to reduce the latency? No, because CloudFront is for external web-based applications. It is not for internal applications that are going to be on the internet. So no, we can't use a public content delivery network for our private applications. We just created a massive security hole in our system. So it's really about actually truly understanding the systems, how the underlying technology works, how the technology pieces fit together, and what problems they actually solve. I have no preferences towards technology whatsoever. The only technology I like is the one that solves my clients' needs. And when I practice medicine, and sometimes I do it as a volunteer, I'm a nurse practitioner, I don't have a pill that I prefer. I don't have a surgical procedure that I prefer. I go in and I find the patient's problem. I analyze their diagnosis. I look at their x-rays, their labs, their MRIs, and I make the appropriate decision based upon their unique needs. I can't have a plan in the head. I can't say, ooh, this new Pfizer drug's good. It's exciting. I got to use it. So we can move on, but I wanted to make sure we got that because these are the dangerous things that we really want to avoid. And that's why architecture is not engineering. So the question I was just answering was, what about if we could use CloudFront Global Accelerator to reduce latency? Isn't that going to reduce latency to the same level as on-premise? Not even close. Even if we could do it, which we can't, a content delivery network will only be was not going to get there because the first time we access the data, it's going to be a cache miss. So the first time we'll have additional latency. And even still, it's not going to cache all of our systems, and we can't use it for private internet data. That's more for internet data. So no, that's not going to solve the latency problem. You can't get faster than the speed of light. That's the problem we're dealing with. So time that goes on a wire. Where can you find slides or notes? You can watch this recording as many times as you like. If we have an actual slide that someone drew, I've shared it. The rest of the time, it's a piece of paper that says, discuss content delivery network or discuss virtual machine strengths and weaknesses, and it won't have any value to anybody other than me. I don't read off slides. I was trained many years ago not to, so that's why. So watch the recording. But I will also say that Microsoft also has on their website some training that you can do that's completely free. And you can read that, and that'll go along with this very nicely. And that's what I would generally recommend. Always go to customer documentations. So let's briefly talk about Azure App Solutions. And what are we talking about here? Let's talk about the Azure App Service. So what is it really? It's a web-based service for building and hosting web applications, background jobs, mobile backends, RESTful APIs. And realistically speaking, here we're talking about another platform as a service type technology. And here we have to where we focus on the website development, and Azure handles the infrastructure, the virtual machines, containers, what have you. And App Service gives you the ability to kind of support a whole lot of versions of code that your developers can do. So it's fairly flexible. It's going to integrate with all kinds of CI/CD stuff like GitHub, which Microsoft owns, Git repositories, Azure DevOps type things. It automatically scales that sort of thing. So I kind of hope that makes sense. So, when the people are building these things, we need to think about lots of different things like the repository branches, whether it's a primary or the stage or development. And there's going to be different stages of development. Maybe they're going to code it, then they're going to stage it, then they're going to put it for production. And they'll typically have some kind of a commit to each branch to trigger the respective deployment slots. And a deployment slot is basically where the finalized builds are ultimately going to be deployed. And they're normally going to be staged. You don't want to go from here, I've been playing with it, to poof, we've deployed it. There's typically some degree of testing and staging. And you can see what happens when it doesn't run right. You can look at like what CrowdStrike did. They clearly didn't do a lot of good testing and enough staging and enough testing, and they pushed it to systems users and took down half of the internet. So there's that. So, that's what we're talking about. And what's going to be the deployment process for our engineers that go and build this? Basically, they're going to commit something to a repository branch, and that's going to trigger the deployment and develop where it needs to go. And that's realistically what goes on. So when we're dealing with Azure App Service Solutions, there's a built-in load balancing and traffic management because we have to. Because if we don't load balance, we're going to have that single point of failure. And of course, when we're dealing with Azure App Solutions, because it's going to integrate so nicely with Azure Solutions, it's going to have its own built-in authentication and authorization service. Authentication is who are you, and authorization or what are you allowed to do. And that way there's minimal code or any work that needs to be done. And it's going to use EasyAuth. Now, I am not a DevOps engineer by any stretch of the imagination, so I had Alonzo draw a picture here. But you can actually see what's going on here, that DevOps is a culture. It merges development and operations. But what you can see here is, you're going to have various stages. You're going to develop it. You need to test it. You need to pop it out there at some point and then move it into production. But it shouldn't be done as a single stage. You want to be able to make sure this stuff actually works before you actually take it somewhere. And that's really what we're talking about. So let's briefly talk about Azure Container Instances. So when we deal with an environment where 98% of clients are multi-cloud, things like the AWS Elastic Container Service, the Azure Container Instances, kind of don't work. So unless we have a client that only wants to be on Azure for some reason, they probably shouldn't use this. And even if they only want to be on just Azure now, we probably should still not use a proprietary solution like this because it's going to make it harder to migrate or move or adopt to a more multi-cloud or a more agile solution later. But having said that, it's going to be on the exam. So Azure Container Instances is going to provide a fast and a simple way to run containers on Azure. So instead of basically running your containers on a single virtual machine and a task, it's going to run in an environment where basically you put your code and it's going to run somewhere. So the thought is that if you've got a container and it's going to launch in seconds. Okay, seconds. Your virtual machine's up and running, so you don't have seconds of latency. So can you tolerate seconds to launch? Now, when these containers run, they run per second billing. So that's one good thing is you only pay when it's running, and it's not going to be like you're going to use it for a second and pay for an hour. We can specify the type of CPU or compute capacity we need, how many cores, what have you. And we can store our container things on, say, Azure files for persistent storage that many containers use. And unlike if it's running on a virtual machine, containers, they typically use the virtual machine library. So if you had a Mac container, it would only run on a Mac. If you had a Windows container, it would run on Windows. If you had a Linux container, it would run on Linux. Or in the new world of Windows subsystem for Linux, you can run a Windows and Linux container on Windows. But with this, you've got multi-OS support. So that is pretty nice. So when you're designing these things, you're going to have the concept of a container group. And a container group is really going to be about a collection of containers. They're going to share a common lifestyle, resources, a local network, and storage environment. So we may have applications that have different container images, the same way we may have multiple applications that on virtual machines that run separately. We can do some source control. For example, we can have a web application container and tell it to pull from the most recent source. We can do some logging from our applications and our containers. And we can create containers for front-end applications, the kind of things that may use that kind of a content delivery network. And we may have back-end services which wouldn't use a content delivery network because they would ride on our private intranet. So some things to think about there is we might use a private registry to make sure that we store our containers in a private environment, such as a Docker trusted registry or an Azure container registry. We want to make sure that the images we actually have maintain their integrity. So we might want to make a hash image or a hash of our containers to make sure they don't change. And we want to make sure that any containers we'll run are locked down. We're not going to want to run out a container image that's got, vulnerabilities in it if we don't have to. And obviously we want to track our files, our network, and our resources. So here was one of those things where I thought I could use a real slide instead of something that says, Mike, discuss this. So of course I had Alonzo make it so it looks pretty. And here you can see a virtual machine itself is completely isolated from any other virtual machine. So we're going to get greater security. Because on a virtual machine, it is separate from a virtual machine. With Azure Container Instances, it's going to be logically isolated from the host. So what's really going to happen is it's going to run on a server of theirs. And if the server were to crash, it'll affect all of these containers. Now, theoretically, one container is isolated from another container, so this shouldn't happen. But, hypervisor security is going to be greater than virtual machine security. Now, when we deal with the operating system, it runs on a virtual machine. It's 100% of the operating system because it's a virtual computer. And that means, running multiple if we've got a virtual machine and we have to run the entire operating system, it's going to use DRAM, it's going to use storage. But on the container, it uses the underlying operating system, so we don't need it. And ultimately, it's only running the application and its dependencies, so it's going to be much lighter weight in terms of the resources that it actually uses. We deploy virtual machines with hypervisor-based solutions. So in the data center, VMware could be something that we actually use. And that we might use, where in this kind of thing, it's typically Docker, Kubernetes containers that we're using. Now, virtual machines use block storage, or we can store it over a network with file storage. Containers typically use Azure disks, which is based, or they can use Azure files, fairly similar. Now, with a virtual machine, if the virtual machine fails, it's going to show up on another server. With containers, and this is one of those nice things about Kubernetes types environments, is we're going to specify we must have 5 instances of this container running. And as soon as a container instance fails, the control plane will say, wait, we need 5. We only have 4 rebooted. So create another one. So that's pretty nice. And generally speaking, I tend to like that. So there's that. So the next thing we're going to get into Azure Kubernetes Service. And what is Azure Kubernetes Service? An Azure managed Kubernetes service. Now, if you're in 3 clouds and you use the Azure Kubernetes service and the Azure cloud goes down, do you know what you have controlling your other clouds? Absolutely nothing. So what do organizations usually do when they deal with a multi-cloud architecture? Either they use the managed Kubernetes platform like OpenShift from IBM, which is what most people do, or they create their own Kubernetes cluster. So in 98% of customers, that's going to be the right solution that are multi-cloud. But there's an exam here. They got an Azure-based Kubernetes service. Kubernetes itself is open standard, so it works great. It's just that you don't want to put your control plane in only one cloud, because if the cloud goes, you lost your control plane. So, great system here. It's a pre-made Kubernetes cluster for you. Gives you all the benefits of open source Kubernetes, and you don't have to know enough to put your Kubernetes cluster together. So that's why people actually like it. So it's because it's Azure done and it's Azure made, it works really nicely and it integrates nicely without you having to think about it, how to get it to integrate into, say, Enter ID, Enter ID or Active Directory, whatever term you want to use to call it. It's going to, because it's an Azure-based system, it'll integrate very nicely into Azure Monitor and give you some good logging solutions. Because it's Kubernetes, you tell it how many cluster, how many instances you need, and your cluster nodes and your pods will scale up and down, but that's just a Kubernetes thing. If you want to upgrade your Kubernetes cluster, meaning your orchestration system, no big deal. You just select another version and Azure will manage that upgrade for you. Where if it was your own, you'd have to upgrade it yourself. When it comes to storage volumes, you can add dynamic storage volumes and static, just like you could any other Kubernetes environment, because all it is Kubernetes. But some design consideration where you think about is, what kind of networking do you need? Do you need communication between 3 clouds or just pod to pod? So that's one thing to think about. Do you use Docker images for your containers right now? If so, you can still do them with Azure Kubernetes Service. Do you need a private container registry? Okay, fine. You could, of course, have your own container registry, or you can integrate this Azure Kubernetes Service with the Azure Container Registry, or use any other kind of public or private repository you want. You could take your containers, your Kubernetes containers from your data center, pop them in, run them directly here in a lift and shift environment, or you can create a new application and run it there. So Kubernetes, the same Kubernetes in any environment. So let's talk about Azure Function. So in the, whether we call it functions as a service, or Amazon calls it a Lambda function, or Azure calls it an Azure function, it's that same kind of concept. You just upload your code and it goes. These are the stateless single run things that are very simple. The key here is they're very simple. There's no servers to manage, and they can be event driven. If this happens, then run this. And they typically support a whole lot of programming language. One thing is these typically scale. And the reason they scale is they just run and run and run and run. You pay for what you use. For the most part, you can run these functions in any language of your choice. And realistically speaking, we can put any kind of system logic we want and basically schedule these kind of things to go one versus another. Now, how do you optimize these functions? Well, these things time out as a general rule in 300 seconds, which is 5 minutes, although you could extend it to 30 minutes if you wanted. You typically don't want to run a long function, something that's going to take a lot of time to work. And for that, and you're going to want to refactor your applications into smaller sets. Because you don't want a function that's going to take a second to kick off or 2 seconds. You're trying to reduce that latency, that cold start time. And if we need to manage state, meaning know what's going on from 1 to the 2, we need to use some kind of a durable function where we're going to manage the state, the checkpoint, the restarts. And we want to do something like this because we may have a timeout of a function and we want to manage that somewhere along the line. So we may want to chain functions together. Do this, do this, do this. And the first function ends and it kicks off the next function, it kicks off the next function. So we may think about how we're going to get these things to scale and perform. So we may have separate functions with each one doing things. And a lot of the functions that have always impressed me are more of these defensive functions. So you've got some problem that occurred, go fix it. You've got an exception, go fix it. And these things typically run best event-driven. Generally speaking, we're going to want to use a different storage account for each function to maximize our performance. And remember, functions can generate high volumes of storage transactions based upon the function and how they're using. Let's talk a little bit about Azure App Solutions. And that's going to be a cloud-based platform for creating and running automated workflows. The purpose here is to integrate our applications, our data, our services, and systems across all of our cloud, on-premises, and hybrid environments. We've got some key things that are pretty nice with Azure Logic Apps. Generally speaking, it's simple. So it's going to simplify us connecting our legacy, our modern, and all of our cutting-edge systems together. So in an enterprise business, we're going to have applications that are 30 and 40 years old and more. And the business is dependent on them, and you can't get rid of them. And they're going to have other things that we actually need to use. And the point here is you can do it together. Azure Logic App gives us the ability to design these workflows step by step by step tasks. And that's going to make it fairly versatile. We do this first, we schedule this to go second, we schedule this to go third. Maybe we've got a custom order that we need to route between something that came in on-premise and our cloud. Maybe we want to take a file that was uploaded to a file server via SFTP and move it to Azure. Maybe we want to monitor social media sentiment, likes, dislikes, comments, negative comments, positive comments. We want to use Azure Logic to kick off an alert or something like that. So that's typically where we're going to use these. So when we deal with Logic apps, it's going to be similar in functionality, but completely different to Azure Functions. In an Azure function, we code it first. In a Logic app, we design it first. What do we want it to do? Now, generally speaking, we should always design before anybody codes, but there's that kind of concept. With an Azure function, we've got to have a developer or we've got to have our AI write our code for us. With Azure Logic App, it's a drag and drop menu and it writes the code for us. Again, taking us further away from that software development. With an Azure function, it's going to have a whole lot of built-in types, binding types. But with an Azure Logic, it's going to have a collection of lots of enterprise connectors. And of course, you can build custom ones. So it's going to be simpler to integrate. An Azure function, we can monitor with application insights. The Logic app we can monitor with Azure Monitor logs like Log Analytics, Azure Portal. So we're kind of dealing with a different situation here. It's a drag and drop no code versus the function, which is code. You're going to see a lot more no code, low code, no code, low code, Amazon Q that writes your code for you, Cloud 3.5 that writes your code for you. So we're moving away. We're getting close to the technology where these applications can be coded and designed from AI. Well, they can't be designed because you don't know what your requirements are, but you can definitely write the code if you tell her where you're coming from. With Logic apps, let's talk about integration. It can be great for integrating multiple applications and systems. But Azure Logic Apps is not going to be ideal for applications that don't have external type connectors. Azure Logic Apps is auto-scaling, so it can scale and process a good amount of data set in parallel without parallel processing. But you're not going to guarantee any kind of fast activation time. And any of these serverless things, that activation time and the time to start the service tends to be slow. With Logic Apps, you can build these complex, deeply nested conditional expressions. So you could use like a Boolean expression if you're familiar with them, or a switch statement, or a loop. And with Logic Apps, you've got these beautiful pre-built connectors. So you've got the ability to integrate into a lot. Now, you could potentially create custom connectors like a REST or a SOAP API. And that can be made with or without writing code. So the question is whether it exists or doesn't. With Logic Apps, we can kind of mix various compute solutions. So we can call a function from a Logic app. So when wouldn't you use Logic Apps? Well, not going to be great for real time because you don't know when it's going to start. If you've got incredibly complex business rules, you don't want to use it. If you're trying to do something non-standard, and it may not write the code for you. So think about it that way, when you would use it. These lower no-code solutions are generally simpler things that you're trying to do. If you're going to use it, you're going to want to really focus hard on optimizing your performance. You want to scale these apps with Logic Apps Engine for some good throughput. You're going to consider parallel task processing. You may come up with these conditional expressions, so that way you can make data-driven decisions in your workflows. You may need to build some custom connections. But the good news is pretty easy to mix and match Azure services because it's an Azure service. Now we'll talk about some messages and event type scenarios. And why would we use these messaging and event scenarios? Well, it's really about application communication. It's about designing how application components can communicate and how critical that is for reliability and scalability. So we're dealing with a communication methodology between messages and events. So when we start looking at these types of systems, we have to think about messages. What is a message? Well, what are the characteristics of a message? It's typically raw data that's made by a component of the system that's used in another. So it's going to include the data itself, not a reference. So typically speaking, the sender is going to expect the receiver to give it something in a specific way. And the system may depend on the sender and receiver. So, and then some key things to know about the message. We're going to have something called the notification. And that's just going to be like a notification in BGP, something unexpected or something happened. These messages can be flexible, so they can be sent to one receiver or multiple receivers. We can deal with the fact that there's really no expectations. The publisher is going to have no expectation that it's of what's going to happen with the receiver. And like anything else, we may want to fan out these messages. So let's say we had an order come in. We may want to fan it out to an email system that said orders here. Let's say the order is a video, and then another message could be sent to video processing to transcode from raw video to, say, an MP4 type file with an H.265 codec. And then we could have another message that says the system is done, go download it. So that's what we're typically talking about fanning out. Point is, when we did couple our systems, which sometimes is great and sometimes is not great based upon the business needs, we have to think about how we're getting our messages from point A to point B. So if we have to think about the difference between messaging and events, sometimes we want to implement both. It's kind of a hybrid approach because some applications will use messages and events for different components. We also have to think about the sender expectations. So with messages, we're going to use it if the sender is going to expect the receiver to do something in a specific way. But we'll use events if the sender has no requirements on the receiver's action. If we need to guarantee communication, we're going to use messages because we can ensure if we desire that all communications are processed and both the sender and receiver are expected to do their things. But with an event, it's not going to be suited to guaranteed core communications because maybe there's no receivers to handle it or there's nobody subscribed. Let's talk about ephemeral communication or temporary communication. Events are ideal when the communication may not need to be handled by any receiver, or if none is going to be subscribing. So we've talked about in the first week some messaging solutions, so let's talk about a few more here. We have Azure Queue Storage. That's where we're going to store a large number of messages in an Azure queue. Like we might in a database. Between the app servers and the database server, we put up a messaging queue. We may also use something like an Azure Service Bus. And that's going to be a message broker to decouple applications, typically more used in these little microservice-based applications or container-based applications. But the key here is Azure messaging solutions can handle millions of messages. And they're typically limited by this Azure storage account. And you can have these messages can be securely accessed globally. And they provide a way to kind of guarantee that your messages will be delivered, just like you would in any other kind of system. So we can briefly address service bus characteristics. And that's going to be a fully managed enterprise message broker. And that's going to support message queues and publish or subscriber topics. And that's going to ensure that we've got some load balancing across all of our competing workers. And this will safely route and transfer data and control access across boundaries. And that's going to help coordinate transactional workloads. So let's think about what goes into designing a messaging solution. Well, first we're going to skip 100% of all those business things we have here, which could take months to figure out. But typically speaking, we need a message queue that's going to be built on a dedicated messaging infrastructure. And we want to make sure that that message queue holds the messages until they're ready. So if we've got 10,000 orders that comes in on a website for a retailer, we don't want to throw them to the database until the database can handle them. We want to make sure the database can handle those transactions so it can write to the transactions and the orders are going to be processed. That's something we're typically going to talk about. So message queues, enterprise applications that might use different communication protocols. Now, by comparison, publish subscribe topics, that's a little different. We can have multiple subscribers per topic, and that can trigger multiple components to do something. Like that can be where you're going to fan out your message. So order comes in to process a video. Send an email to the team that this is ready. Send another thing to a system to actually go process that video. Send another one that when it's completely done that says, here's your download link, go download your video. So we can set up triggers to look for. So how do you choose between messaging service? Well, it depends what you need. You're going to use a queue, which is optimal for organizing messages. You need an audit trail, and you don't expect it to be huge. So if you need to track to process the message in a queue, use a queue, a simple type queue. Now, if you need other functions, this is where you're going to use the service bus message queue. If you need delivery guarantees, service bus queue, because it's going to require at most that every delivery is delivered at least once. If you need to group transactions into a single thing, use service message queue, but service bus message queues. If you've got large messages, larger than 64K, use Azure Service Bus message queues. If you've got to batch certain things like publish and consume batches of message, use Azure Service Bus message queue. So a little bit more about choosing between these messaging services. If you've got multiple, Azure Service Bus is great for these publish subscribe. If you need multiple receivers to receive the message, kind of in that fan out sort of thing. If you've got multiple destinations for it, use Azure Service Bus message queue, as opposed to the database where you're using more of that simple queue. Chris, how long has it been since our last session? Okay, let's briefly take some questions here. And I am not an application architect, so I'll do my best on this section. What's the difference between Kubernetes and Azure Container Group? So Kubernetes is a full container orchestration platform that is non-proprietary. So Kubernetes works in our data center. Kubernetes works in AWS, Azure, Google, Alibaba's cloud, the Oracle cloud, and any other place you would want. By comparison, the Azure Container Group and Azure Container Instances, which is going to include Azure Container Group, is a simple, highly proprietary service for running containers. You don't have as much complexity of container orchestration. So single cloud, not much sophistication. The people don't have the sophistication to run something more complicated. That's where you're going to use it. So AWS has this thing called ECS, Elastic Container Service. And I typically tell people that you probably should never use it, because if you use it, you're going to lock yourself into that single cloud, and it's going to be very hard for you to move later to other platforms. Same thing for that Azure Container Instances and Azure Container Groups. It's proprietary. So proprietary locks you into a lot of challenges. And if you use proprietary now because it's easy, and then the business needs change, and you need a more open standard to be able to interact with somebody else's vendor's technology, you are done. So many years ago, we used proprietary, and vendors love to sell proprietary because it's kind of like the song from the Eagles, Hotel California. You can check in anytime you want, but you can never leave. So it's like being handcuffed to the vendor once you use these proprietary things. Whereas if you use Kubernetes, it works for anyone. You don't have these problems. Great question. How do you design a network for Kubernetes? So the first thing is you need to know networking. That means IP addressing, subnetting, supernetting, where you route your messages, various routing protocols such as BGP. And that's something that network architects like me or Mark Milovanovic do. And the people that are going to design it here are going to be there. Now, I could tell you very simple things that you could use, things like CNI plugins like Calico, and that'll kind of help. That you can use VPNs or interconnects, but I don't know whether you should use a VPN, and I don't know whether you should use a private line. I don't know whether you need 1 megabit a second, 10 gigabit a second, or 100 gigabit a second, or multiple 100 gigabits a second per cloud. And that's going to be based upon your application patterns and your traffic patterns and what you're using. I also don't know what your latency needs are. Could it be tolerant of an IPsec VPN with variations in latency or jitter, or does it need to be guaranteed performance? So we need to think about that. So these are the kind of things that go in there. We can assist it with things like DNS-based service discovery and service messages for traffic. But we really need to understand what our performance needs are, because even designing that networking thing could take months. I mean, and that's why a network architect, that could be a year just to learn this networking piece, or actually 2 or 3 years, depending upon where you were trained. I can tell you right now that network architecture is about 1 million times harder than cloud architecture for the most part. But, it's not complicated for me. It's about as a network architect, but really what is the performance? What kind of links do you need? What kind of routing do you need? Do you have overlapping IP addresses? Hopefully you don't, but if you did, you'd need NAT. Where do you have two direct connections to each cloud provider? Do you want to load share across one link versus another, which is going to determine your traffic engineering, which is going to be based upon your BGP policy? Do you need a private line? Can you use a IPsec tunnel? Can you kind of get somewhere in between it by using an IPsec tunnel along with software-defined networking? Would it be better, instead of dealing with the complexity, to use a SASE WAN? So all this stuff goes in there, but that actual question is 1,000-hour answer and 1,000 hours of training. It's a great question, though. I'm glad you're thinking of it. And that's why we architects have to build an architecture team, because there's no one person that's going to be able to do that. The people that know how to do that, like me and Mark, won't know much about APIs, because that's not our world. So we'll have to bring in an application architect for that. And the people that know big database, the big database, like the data scientist and the what do you call it, the data architects, won't know networking. So that's why it's all about the creation of an architecture team and the leading of an architecture team. And that's why most architectures take 6 to 12 months with a team of 15 to 50 people to design them, let alone the engineering team after we leave that go and build it. Good question. How do you reduce the cold start problem with Azure lock objects? So if you've got a high performance application, don't use one of these things. Use a virtual machine. So the first part is about knowing what technology to use when you use it and what's going to meet your business's needs. And then if you're going to use these things, well, what you're trying to do is you're trying to minimize that latency or cold start time. So you're going to try to really optimize your code and make it there. The other thing you can do is you can pre-warm your instances. So you'll keep these things running all the time, like an always on configuration. Now, if you're paying every time one of these silly things runs and the only way you can get the performance you need is to keep it running all the time, maybe think virtual machine and don't do these things, but there's that. So you can use a premium plan or dedicated plans to kind of keep these instances warm, but it's really about optimizing the code and the dependencies to try to minimize that time or keep these things running. And if you keep them running, maybe you should be using a virtual machine in the first place, which is going to give you better performance in every way, shape, or form. And that's why it's like there's no best technology. It's all about what do we need to do. Again, great question. Good thinking. All right. Well, I will go back to the content. There is a good chance we're going to actually have to run an additional day next week. Thought we could do this in 2 weeks. Maybe we need 2 weeks and an extra day or two, but I want to give you guys, great training with lots and lots of information. I'll know exactly how far we're going to get by the end of the day tomorrow. So let's talk about using Azure Event Hubs as a messaging solution. And what is Azure Event Hubs again? I mean, we talked about it the first week, but we'll briefly talk about it. It's a managed big data streaming platform and an event ingestion service. The point here is we're going to use it for real-time data ingestion. So we've got data coming in. And we typically use it with microservices batching on the same stream. So if we've got data coming in that needs lots of processing and analytics, and some characteristics of event hubs is you typically can use lots of different languages. And it typically is compatible with Apache Storm, which is great for message reception. We can provide some data stream ordering. So basically events are added at the end of the stream in the order they're received. But if you need to, you can use like time offsets to kind of tune this a little bit. Basically, it's a pull model. So, when the messages are in the event hub, of the consumers that are going to use this are going to pull the messages there. So the messages won't be deleted after being read. And that way you can have 1 or 2 or 3 devices that need the same message to do these things. And it's going to scale. And it's going to scale according to the number of purchase throughput you need. And of course, you can buy various performance tiers like basic, standard, or premium. Some key points to remember is that it's going to be a common type implementation. And we're going to get some live dashboards, real-time updates. We can get an analytics pipeline. So think about clickstream analysis. You got a bunch of people hanging out on your website and you're clicking stuff and you're trying to figure out their usage patterns or how to tune it. Or how does that website get re-architected to maximize sales or whatever you're trying to do. And it's going to support a wide variety of languages and frameworks. Now, when you're dealing with this Azure Events Hub messaging solution, it's priced on throughput units. And basically, you're going to, from an ingress perspective or taking in, you've got 1 megabit a second or upwards of 1,000 events per second, whichever is going to come first. And we can push it out. Remember, I said you can have multiple consumers at up to 2 megabit per second or 4,096 megabit or events per second. So what you'll have to do is choose a pricing model that's going to meet your organization's needs. And because it's a pull model, these messages can stay in a cache after being read. So we might have multiple systems dealing with this. So lots of times you've got an environment where multiple consumers are going to need to process the same data. Now, let's talk about designing an event-driven solution. So first, again, what is that event-driven architecture? When one thing happens, something else has to happen. I did this wrong. Go fix it. That's event-driven. And you can lots of examples of event-driven things in life. You walk into a store, it sends a ding, 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 and all of a sudden the sales rep comes to you. That's event-driven. The sales rep could have been in the back sleeping until they heard that thing and it woke them up. It could be, typically speaking, something happens in your system, like some system's been hacked. It sets off a notification. It does this. It does this. That's realistically speaking what we're talking about. So the point is you create these systems event-driven and you set them and you forget them. And basically they're there. And as soon as something happens, it does its thing. It does what it needs to. The key point is you don't really have to run these systems all the time. The publisher, for example, of something doesn't need to worry about the subscribers. We can have this one-to-many relationship where something gets set up and it kicks off multiple things. And it happens because something else happened. So when we're dealing with these event-driven environments, typically there's some kind of function as a service. We also have this concept of the Azure Event Grid. And that's an event routing service. So it's a service to manage these events as they're going to occur. And it's going to make it easier to build these event-driven applications. So what are we talking about here? We're talking about taking the events and routing them to where they need to go. So maybe we've got a source and we want to send a source and it's coming from Blob storage. And we want to do something with it. It's going to help us manage the delivery of whatever these events are. And that way we don't need to pull for tasks. We've got something that's going to move it for us. So when we deal with these, we have a couple concepts to think about. We have event sources and topics. And event sources basically tag events with topics, and they're going to send them to an event grid. Think of event sources like Blob storage, Azure Media Storage. Then we have to have something that's going to handle events or handle the subscriptions to a topic. So let's talk about some event handlers like Azure Functions or an Azure DevOps webhook. And then we have to route it somewhere. So basically speaking, Event Grid will evaluate the topics tags and to route events to whatever handler they need to go to. And it'll forward these events to the various subscribers. And what will happen, it'll send an event in a change with a URL or identifier to the changed object. So remember, you can use multiple services here for your design requirements. And you're typically speaking going to use some kind of a service role. So with Azure Event Grid, it's going to distribute our events. We might use it Azure Service Bus to process messages. And the point is, it's going to link various services together. And that's honestly, all we're going to talk about these event-driven things. Now, caching. Lots of uses at caching. We're going to have caching in our content delivery networks. But in this particular case, we're actually talking about Azure Cache for Redis. And why might we actually use this? And we might use it for the following reasons. We may have a database where people are accessing the same information routinely. And if they're going to access or pull the same information routinely, guess what it's going to do? It's going to reduce the latency. Now, if we put a cache on information that's all different, what does it do? It increases latency. So we have to know what we're doing. Now, we can obviously just set up a Redis cache if we want on a virtual machine with lots of DRAM. Or we've got kind of this Azure cache for Redis. It's the same concept. Point is, it's going to be a low latency, high throughput cache for lots of volume. And all kinds of Redis type functionalities. We can use it for distributed data, content caching, session stores, or message brokers. So when we think about it, we have a couple of kinds of caches from our application architecture patterns. We may have a data cache. So we're going to have a database, for example, that's so large that we can't all put it into the cache. So the solution here is basically to cache certain patterns and load data into the cache as needed. And that's why caches are good for information that's frequently accessed. You're not going to typically put everything there. We can also create a content cache. So there are certain parts of your website that are not going to change, like a header of your website or the footer of your website or a banner. We can store this stuff directly in a cache, and that way when people are going to go to that page, that stuff that's common among all of our pages is going to load ahead of time without hitting the web servers, further reducing the load on the servers. We can also use it as a session store. So maybe we have a scenario like we've got a shopping cart and it's got user history data. And we may be using that in-memory cache to associate, say, session data with the user. So we don't have to have this performance impact of a whole lot of cookies that we're storing. We could use this cache with regards to a message queuing. For example, let's say we've got an operation that's going to take a long time to continue or complete. We could put a distributed queue in and defer longer running applications to, say, a task queue. And that way it'll be processed sequentially by another server. Or we may have a distributed transaction. So we may have a bunch of commands that have to occur against the backend data store to assess that's going to execute a single expression. And this type of environment, the Azure Cache for Redis, will basically support executing a bunch of batch commands as a single transaction. So when we think about cache, we need to think about various patterns like the data cache, the content cache, the data store. We need to determine which patterns are going to apply. And we need to think about the performance and scalability that we need. Because if it's constantly varying information, these caches will really, if it's constantly the same information, these caches will improve performance. If it's different information, it will enhance latency and further damage solution. Sorry about my sniffles. My cat sleeps on my head. I'm allergic to her, but she's cute and I love her. So there's that. So when we design caches, we need to think about security, obviously. So we want to make sure that we're using secure and dedicated caches. And we need to think about cache management policies like how long does it take do we want for information to expire from the cache? Because we need some kind of consistency and reliability here as well. Now, when we talk about designing APIs for integration points, and again, this is not my background, we have to think about why. So when an organization publishes an API, it adds the ability to integrate into their systems. Now, you've got an application that easily integrates into various systems. That means more people are going to want to use it, which means the company will generate more revenue, and it typically fosters innovation. Closed systems, much harder to do. Now, if you think about designing APIs, you're going to have some challenges because you're going to have to onboard users and show them how to use it. You're going to have to manage revisions for the thing, and you're going to have security on your APIs. So, of course, Azure has some API management. They've got a platform to publish, secure, and maintain and analyze your APIs. And basically speaking, that's going to act kind of like that front door for all your APIs, routing your information to deployed servers. And by doing so, it's going to reduce the complexity in managing and supporting a whole lot of APIs. And they're going to give you some tools for doing so. Now, when you consider these things, you need to think about the number of APIs you have. Because the greater number of APIs you have, the more you're going to need to come up with a standard deployment and a centralized control. You also need to think about the rate of API changes. So if you need frequent changes, now you're going to need some form of version and control. And you need to think about the administrative burden or load of these things. So you may need to define some kind of a policy, whether it be a quota or a rate limit. And the more configurations you have, the more you need to standardize. And that goes with any business. If you're going to go to McDonald's and try to sell 100,000 hamburgers in a week, they're going to have to be all cookie cutter. Whereas if you go to a Morton's for a steak, it's going to be slower and it's not going to be as standardized, so you can get it the way you want it. And that's one of those enterprise architecture operating models where you're going to have to try the same concept here. So, do we use a standard API or we use disparate solutions? How do we enhance the API security? Things to think about. So, we need to manage permissions, access, protect our APIs from malicious code. Let's talk about automating our application deployment. So, in an agile type development environment, we need to have quick iterations and reliable infrastructure. And we need to be able to pop it out quickly. So, I don't want to have a bunch of junior level people clicking on a bunch of boxes in my business and making manual errors. I want 1 or 2 or 3 or some senior level people that can come up with an infrastructure as code script and deploy all of this stuff in a sophisticated manner without making as many errors. So when it comes down to it, there's a couple of ways we can actually typically do infrastructure as code. We're going to talk about a declarative approach here, where basically you just define your infrastructure and the configuration for it. You describe each resources, but not how to deploy it. And why won't we use something like this? These Azure resource templates. Well, we're going to get the same result with repeated deployments. We can deploy these resources parallelly at the same time. So very fast, lots of resources. We can use templates and we can validate them before we deploy them. So we're going to find errors before we deploy them. We can take these templates and modularize them and break them up into smaller components and then do them. And we can run deployment scripts. Even like we can take our system, launch an Ubuntu Linux system and tell them to do that sudo apt-get update and update the operating system, or install an Apache web daemon or something like that. Now, when you're writing these Azure Resource Monitor templates, you can use JSON. You can use Azure Bicep, which is a Azure proprietary language for syntax. And what happens is Bicep will convert the Bicep command line will convert your JSON template to a Bicep template. Although most businesses will use some form of Terraform for all their clouds, because 98% of enterprises are multi-cloud. So that might be a better solution. Bear with me one second. But Azure Bicep templates are going to use a domain-specific language. They're used for that same kind of declarative deployment. But Azure Bicep is specifically for Azure, whereas if you're dealing with Terraform, it'll work on all clouds. So if you're not going to use Terraform, which most businesses would, or some open standard like Terraform, what you really need to do is use something like Bicep. It's native to Azure. It's fully supported by Azure. It handles state management. It handles easy transitions. You want to come on? You want to come on camera real quick? Hold on 1 second. I've got a little baby here in case anybody wanted to see my little baby girl. She's beautiful, but she doesn't like to be held. Her name is Cindy here. Say hi to Cindy. Okay, Cindy, I know you really don't like to be picked up or on camera. She's a little bit shy. She came in to say hello, and I'm sorry, Princess, for putting you on camera. Okay, I get it. You're going to attack me for telling me that. I'll give you some lollipops when we're done. So there is that. Now let's talk about designing automated app deployments. So we have this concept of Azure Automation where we can basically deploy certain things in a configuration service. So this can manage some Azure and non-Azure environments. It can process, and we can provide control of a process to automate our configuration management. The point here is we're trying to automate things. So you want to automate your frequent, time-consuming, error-prone tasks. Why would a business do it? They need less staff. And there's less likelihood for errors. So typically speaking, there'll be some author run books that'll be in PowerShell or Python. And again, that reduces errors, but it improves cost by reducing the number of engineers needed by the business. And, it's not my goal to reduce staff, but it's the business's goal to do so. So you got to always look at what's going on business-wide and the trends that are going on here as you think about your career. The point here is it's going to give you configuration management with these automated app deployments. So it can change your tracking, your inventory, your state. It tracks changes across your services, your software, and it can diagnose, problems or alerts. And by doing so, you can manage your updates from your Windows and Linux systems, basically update all these things today, patch at this level. But of course, you want to test these patches before you do it. Update these systems in the middle of the night at this time, for example. So I'm going to give you some Azure guidelines on networking. These guidelines don't even scratch the surface of networking. I mean, it's nothing compared to what you would need to know networking wise, but I'm going to give you what you may see on the exam. So when it comes to networking, don't be confident in this. My team can give you some more networking things. Chris, provide the last BGP session. That'll be some networking, and provide the subnetting one. That'll provide some networking guideline. That'll help a lot. It's not enough. You can also provide the what is SASE and what is software-defined networking. That'll provide a little more. And that'll help because that'll add about 15 hours of networking training here, as well as the discussions that we had with Aviatrix. And that 15 hours will start to scratch some more of the surface of networking. That'll maybe get you like 5 to 10% of what, what the networking that's there that we need to know as architects, but at least it's something and it's all free. So some things that they design are naming. So establish consistent naming convention of networking resources. And in the region, so what we're really trying to do is determine based upon what regions we need to put our systems. And meaning, why do we want them closer to the user? Some guidelines that we can tell you are that your IP addresses inside of your VNets have to be private addresses, generally speaking. And you can look at all the private addresses, and they're going to be listed in RFC 1918 on the Internet Engineering Task Force website. That means the 10.0.0/8 address space, the 172.16.0.0/12 address space, and that 192.168.0.0/16 address space. So think about those IP addresses. And we want to segment our networks. Now, on the data center, we're going to segment everything in VPNs and route between them and And we might even segment our systems in the same VLAN with a private VLAN so they can't even talk to each other. We don't have any of that in the cloud. So the closest thing we can do is segment virtual networks or subnets, create a bunch of VNets and maybe peer between them. We can define some network security functionality with regards to, say, network security groups. And that's really what you're doing. And you may honestly create a different IP address space for various things. You should have one address space for your front end stuff, a different address space for your private stuff, and you want to segment these heavily. And by doing so, you can run ACLs and firewalls, what have you. So you want to really think about the number of network interfaces you have and consider limiting them. On the network security group side, it's a packet filter to determine who can go up. And you also want to adjust your routes. Like if I separate two VNets and I don't provide routing information for a certain subnet, you can't reach it. So that's going to be some of the things that you want to do. And obviously, Azure's got that same concept of a virtual router. So there's that. Some best practices are to plan out your IP addresses ahead of time. And, maybe, you deal with the /16 CIDR range, because that's going to give you about 65,000 addresses. And maybe, you may have one account that's there, another account that's there, and you can do some peering between them. Try not to use overlapping address spaces when possible. And if you have overlapping address spaces, then you've got absolutely no choice but to actually use NAT to get your systems to communicate. Generally speaking, these things on the cloud typically use hub and spoke, meaning you've got your central location and you've got your various spoke sites. Of course, you can do some combination of fully meshing. You may have one virtual network for certain business functions and another one. You may want to use a firewall for traffic control in between things. So you're going to want to use your network security groups because it's one of the few things you can actually do to separate your VLANs here. It's not like we can do in the data center where we've got a lot of control. So the closest thing we can have to actually micro-segmentation would be to the creation of multiple VNets and then do VNet peering and determine who peers with whom. So maybe we've got one subnet for a database workload and another subnet for web workloads and another subnet for routing in between these systems and another subnet for an HR application. And then we're going to basically set up a security group, like a network security group that says this one and this one can actually talk to each other. So there's not a lot that they actually talk about in this exam. So let's talk about outbound connectivity. So outbound connectivity is going to the internet. Now, inside of your systems, generally speaking, you're going to put a private IP address on it. And things that need to be reachable from the internet get a public IP address. So typically speaking, you've got a load balancer that's going to front end your web servers. So that load balancer is going to get that public address, and your web servers are behind that load balancer. But when it comes to reaching out to the internet and it comes to NAT, there's going to be a lot of different kinds of NAT. So basically, we have static NAT. Here's static NAT. The local IP address of 10.0.0.1 maps to 1.2.3.4. And if you reach 1.2.3.4, it always maps back to that original source. That is static NAT. When would you use that? You're a business, you bought one company, and they're using the overlapping IP addresses, but you must reach that server, you use static NAT. because you need to be able to reach that server all the time, and the IP address can't be changing. Battery on my earpiece is dead, which I use when people. So let me go swap earpieces. They get used a lot around here. And I may sneeze from my cat allergy. Bear with me 1 second. Okay. Now we also have the concept of NAT overload. Now this is what you typically think of in most environments. What's really going on here is you've got a public IP address for your business, and you've got 100 users behind the firewall, and they all get translated to that single public user. That is called NAT overload, otherwise known as port address translation. And that's typically what you would use if you've got 1,000 virtual machines and they need to go out to the internet to update their operating system or patch, but you don't want external connectivity in. That would be NAT overload, and that's typically speaking. So with Azure, we can do the static NAT, and you now know why we use it. We can do that NAT overload that we're also talking about for outbound. So let's talk about routes and routing tables. So let's pretend I'm a router. And the way what routers do is they build a map of the routing table. And the routing table might say, to get to 172.16.1.0/24, go out that link. But to go to 10.1.2.0/24, go out that link. And that's realistically speaking, they're building a map of the network. So typically speaking, what you actually have here is the following. So you're going to have your system routes. And basically, they're going to be automatically created when you connect your VNet. And that's going to basically be to connect you to any subnets that you put in there. You can also create some user-defined routes. Basically speaking, that's going to be a static route. To reach this subnet, here's your next hop IP address. We obviously will need routes if we're going to connect to various VNets, because we can't reach anything without a route to it. So if I've got my VNet and I've got another VNet, I need to put a route on the routing table to do so. We can also learn routes dynamically. So if I'm going to connect to the cloud provider, I can manually assign all routes, or I can run BGP to the cloud provider and learn routes dynamically, which is what I'm going to use. So anytime you connect to the cloud provider, you're going to be using BGP. We also will need to reach certain endpoints of various services. And how do we route to an endpoint? We put a route in the routing table. Maybe I'll do a workshop on what is routing one day. If people want me to do a workshop on what is routing, let me know. Maybe Mark Milovanovic and I will do a workshop on what is routing. Let us know in the chat box. Well, basically speaking, the way routing works is you take the most specific route first. So what do I mean by this? If I have a route to 172.16.0.0/16, that is going to be less specific than 172.16.1.0/24, even though the 172.16.0.0/16 includes the 172.16.1.0/24. It's an aggregate route or a supernet route. So first, the priority of the routes is and always will be the most specific route. The next specific is static routes, because if I manually tell you a route, it's typically more reliable than than a routing protocol or run route. So longest route first, then a user-defined route or a /static route, and then a BGP route, and then a system-defined route. So system-defined routes basically are going to be there, and they define specific locations and scenarios. Generally speaking, it's going to be traffic between virtual machines in the same VNet, your VNet to your VPN, that kind of thing. User-defined routes are those that you manually tell it. To create a default route, go out the internet through your firewall, so you will. Or go out to this custom network appliance to do something. Manual static routes. And sometimes we may want to use one routing protocol over another to force a route to go a certain way. We might do forced tunneling. So everything has to go through this particular path so we can inspect the traffic as it goes out to the internet. That might be the kind of thing we may need to do. So designing, actually, you know what? We're actually 10 minutes before. I think I'll take questions now. Chris, let's bring in some questions. With Event Hub, what happens if the consumers process data more than the producers produce? So if the consumers process data slower than the producers are actually going to be able to produce it. So if the consumers process data slower than the producers, what's going to happen is the data is going to accumulate in Event Hub. And if it exceeds its retention limits, it's just going to time out and the data might be lost. By comparison, if the consumers can produce data faster than the producers, they're going to have to wait for new events to arise. So typically think we want to balance, that producer and consumer information to help prevent bottlenecks. And while we wait for Chris to bring in the next question from Freedom Lands, does Cindy still have claws? Yes, Cindy has lots of claws. She's used it to pick up the carpet, put holes in a few different things, but she definitely has claws.
So for some reason, this next question isn't populating on our streaming platform, but it's on YouTube. The question is, what? Let me find it again. Which of these support first in, first out, and what supports fan out? Presumably on the services that we're discussing.
Okay. So
I don't know why it wasn't coming into the to the platform here.
Okay. So obviously we couldn't put that question up. So which supports first and first out and which supports fan out? So first and first out is going to be supported by Azure Service Bus Queues. With AWS, it will be SQS. And fan out is typically supported by Azure Event Grid. And if we were looking for the AWS equivalent, it would be Azure SNS or Simple Notification Service. With AWS Kinesis, I'm trying to understand this. With AWS Kinesis, can't write straight into storage. It has to first be sent to Firehose prior to data store. Is that the same case with? I'm not sure I really understand the question. So let me try to think about it and translate this into my mind because I'm struggling with the language. So maybe the question is with AWS Kinesis, it can't write straight into storage. It first has to be sent into Firehose before you store it. Is that the same case? So no, in Azure Event Hubs, which is very similar to AWS Kinesis, it can write data directly to storage, like services like Blob or Data Lake. So we don't need that intermediary service. So we can still use tools like Azure Stream Analytics for data processing before it gets stored, though. Can I please discuss transitive routing in Azure? Actually, yes, in the first week, we spent quite a bit of time discussing transitive routing. But I'm happy to discuss transitive routing. I will, again, I have no problem with that. So bear with me. Here's what we're really talking about with regards to transitive routing versus non-transitive routing. So in a normal routing environment, let's say this is router 1. I don't know what I did here. And this is router 2. And this is router 3. And this is what we would have, normally speaking, in our environment if we were running an interior gateway protocol, such as OSPF, intermediate systems to intermediate systems, EIGRP, heck, RIP version 2, which is a really icky protocol from 1,000,001 years ago. Here's what it realistically talks about. So let me put a link between these two and a link between these two. Let me pop an Ethernet segment over here. And let's maybe put it more central so you guys can see this. And let's say we've got a web server here. And let's just say we have a server. It won't be a web server, a server. And then let's say we've got a client over here. So with normal routing or transitive routing, what'll happen is, let's say router 1, router 2, and router 3 are running an interior gateway protocol. And let's say it's OSPF. So what'll happen is each one of these routers will send their will generate something called a LSA, or a link state advertisement. And every router will maintain a route to every subnet inside of this network. And that means that C, well, basically, if it has to reach the server, what typically is going to happen is you've got the consumer that's on a PC. And the PC typically has something called the default gateway. So if the PC wants to reach the server, the PC is going to look in its routing table and say, do I have a route to the server? And the PC won't, but it'll have a default gateway that says, if you don't know where to go here. And that's going to be the IP address of its first router. Now that first router is going to look in its routing table and it's going to say, do I have a route to the subnet with the server? And it does. So it will send that packet directly to router 2. Now, if it's an Ethernet link, what'll happen is router 1 will say ARP, who has the MAC address for router 2, or for the server. The router 2 will proxy ARP and say, I have this MAC address. And then the packet will make it to router 2. Then router 2 will look in its routing table. Do I have a route to the subnet with the server? The answer will be yes. So then it will say who has the MAC address, because it's on Ethernet, of the server. Router 3 will proxy ARP. Now at this point, the route is on router 3. Router 3 is going to look in its routing table and say, well, yes, I have a route to the server. It is directly connected. And then it's going to send an ARP broadcast. Who has the MAC address for this server? And it'll come out as an all-F broadcast, and the server will respond, and then the packets are routed back. This is transitive routing. And why is it transitive routing? Because router 1 told router 3 its routes, and router 3 told router 1 its routes. And that way, everybody knows how to reach everybody. Now, in non-transitive routing, we have the exact opposite. And when we're dealing with non-transitive routing, it's quite simple. We tell the routers they're not allowed to share routes. So what does this mean? It means router 2 will know router 3's routes, because it'll learn router's 3 routes. But it won't pass router 3's routes to router 1. And because of that, router 1 will have absolutely no idea to reach router 3. And router 1 will tell router 2 router 1's routes. But router 2 won't tell router 3 its routes. So what you'll have here is router 1 over here will be able to reach anything at once that's sitting off of router 2. And router 3 will be able to reach anything off of router 2. But router 1 won't be able to reach router 3 through router 2. So it won't work. So how do we make this transitive? Well, what we have to do is We have to break things. We have to break the rules of non-transitive routing. And where did all this come from? 20 years before AWS had Transit Gateway, we had the same problem with internal BGP. And basically, with BGP, this would be an autonomous system, this would be an autonomous system, and this would be an autonomous system. So we created something called a route reflector. And a route reflector said, woohoo, we're going to break the rules of non-transitive routing. So router 3, tell router 2 its routes, and then pass those routes on to router 1. And by comparison, router 1 said, no big deal. I'll send my routes to router 2 and router 3 will do it. And that brings us back to normal transitive routing. The other way to deal with non-transitive routing is as follows. We fully mesh everybody. So what does that mean, fully mesh? It means that everybody has a connection to everybody. So that means that we'd have a link which pushes the routes from router 1 to router 3. We'd have another link from router 1 to router 2. And we'd have another link from router 2 to router 1. And that would work perfectly. There's only one problem here. Fully mesh uses this icky formula of n times n minus 1 divided by 2. So here we've got 3 routers. It's no big deal. What if we had 10 routers or 10 autonomous systems or 10 VNets or 10 VPCs? Well, we run into this formula of 10 times 10 minus 1, which is 9, which is 90 divided by 2. Now we're going to have 45 of these connections. So that's really what transitive routing is. So all Transit Gateway, all Cloud Hub, all any of this stuff is basically saying, don't worry about non-transitive routing. You're allowed to pass the routes on. That's it. It's a 35-year-old BGP technology. Let me try to rearrange this so I can see. What about application security group? Can we throw more light on that? So application security groups are really a basic elementary form of network security. And instead of having a network security group for each thing, you're basically grouping certain things together. So let's say you group a bunch of virtual machines based upon the roles and applications, and then you apply a network security group to all of those systems that were attached there. So realistically speaking, that's what we're honestly talking about. No big deal. It's a network security group that's applied to multiple things with a single thing. And we could use it for VNet integration for outbound to map connections. We could use it for secure inbound access to your app service where you'd set up some private endpoints and manage your traffic using network security groups, which again would be tied to your application security groups. What kind of software do you use to document these hundreds of internal network addresses and mapping? Microsoft Excel in most cases. Potentially Google has Sheets, but most businesses use actually Microsoft Excel. So I can tell you from an architect perspective, these are the applications you use. Microsoft Word for all your RFIs, RFPs, RFQs, documentations. Microsoft PowerPoints for your diagramming as a rule, or you could use Microsoft Visio, but generally speaking, a lot of it's via PowerPoint. Microsoft Excel for these kind of things and business calculations. And that's pretty, and Outlook or whatever email program you use. How do you connect a subnet with an overlapping IP address? Use network address translation, specifically a static mapping so that you're there. So that's all you're really going to use. You have to translate the addresses because you can't have two systems with the same. So that's why we use network address translation. Any others, Chris? Since time is limited, please speak on an SQL pool affecting Azure Synapse Analytics. So I will tell you that I am not a big data architect. I am an enterprise architect, a network architect, and I've done security architecture and cloud, obviously, but not big data. But in Azure Synapse Analytics, an SQL pool is kind of that dedicated what data type warehousing component that's going to provide us, that high performance, scalable storage and querying capabilities. And it's typically, to the best of my knowledge, going to affect Synapse by enabling complex queries and analytics to run on a large data set. So that should provide some resources for processing data in parallel across a distributed number of compute nodes. Thank you, Derek, and it's always good to see you here, Derek. Phil, you want to learn more networking things? I'm sure Mike and I can have some funny networking things that we love to talk about. Networking has been my life for a couple of decades, and I absolutely love it. You are most welcome. We really want to go out there and give the best we possibly can to the community. So let's end on these for today. We will be back tomorrow. And on tomorrow, we will continue the content. Depending upon where we finish tomorrow, we may have to continue back on probably Tuesday next week. My goal was to get this done in 10 days, but here's the thing. I drew a lot of diagrams in that first week, and I tried to do as many questions as I could, to try as many as I could. I can't answer every question, but I tried. And I wanted to give you as much value as we could in this free training session. So if you're not a subscriber, and I would do Monday next week, but I'm actually doing something with aviatrics on Monday, so I just don't have the opportunity to do it on Monday, and my schedule is fully loaded with teaching classes. But we can come back Tuesday if we don't finish tomorrow, and I do want to finish the content because I want to make sure we give you a lot. And if that's the case, what we'll actually do is we will go out there and share the link of the new training session if we actually do it. And I'll share all these things on my LinkedIn. If you had a good time, maybe give it a like, maybe subscribe to our channel, hit the bell to be notified, and we will take it from there. Give me a hashtag AZ305, and we will take it from there. And I look forward to seeing you tomorrow.